Okay, so I want to do these two questions, and then I want to move on to either trigonometry or differentiation. Either one of those two. Let me just decide from now. What are the feel to the thinking about? Differentiation or trigonometry? Let me hear.
Differentiation.
Is that something you guys did before?
No.
Nah, you've heard about it though?
Yeah.
Yeah, don't worry, it's not as evil as people make it seem. And Virginia?
Mm.
Yeah, it's really good.
Yeah, big up Virginia in that exam. 2012. So do you all remember APs and GPs from like last time? I was like last year or something. I was like a long time ago. I was like the last century.
I don't really like APs and GPs.
We will see. Come on, you remember APs and GPs?
Yeah.
Yeah, okay, well, you're gonna help me with this question,
Oh,
right?
go. Okay.
Yeah, so come on, give this question a read from her.
A customer repays a loan monthly by increasing the payment each month by dollars X. If the customer repaid $50 in the fifth month and $70 in the ninth month, calculate the total amount of money repaid at the end of the 24th month.
Okay, so first of all, come on, you think this is a AP or a GP? What do you think?
And AP
I agree. Remind me, what's a AP? What's a AP?
is arithmetic progression.
Right, and what do we know about our arithmetic progression? What do we know about it?
Um, you have to find the common difference.
Right, so the terms linked together by adding a number or multiplying by a number, if you had to say. So
Um,
like, let me give you two sequences here, and I want you to tell me which one looking like a AP. Talk to me. Which one you think is a AP?
um, the second one.
Nah.
Okay.
All right. So just like I'm gonna get a quick crash course, right? So come on, yeah. To get the next term for this sequence, what am I doing? What am I doing with 5 to get 7? Talk to me.
Plus,
What am I doing with 5 to get 7?
plus and three.
I wouldn't
No,
say
two,
plus,
two,
right?
two.
That's okay. What am I doing with
Yeah,
7 to get 9? 7 to get 9.
plus two,
What am I doing with 9 to get 11?
plus two.
Yeah, yeah. So, does it have a common difference or common ratio?
A common difference.
Yeah, because watch. 7 minus 5. What's 7 minus 5?
Two,
What is 9 minus 7?
two,
What is 11 minus 9?
two.
Common difference, right? The other one, um, are the terms linked together by adding a number or by multiplying by the same number throughout?
Multiplying by the same number.
What number we multiplying by throughout? Here.
Two.
Aha. So anytime you're repeatedly adding, it's a what? If you're repeatedly
Arithmetic.
good, and if you're constantly multiplying, it's a
Geometric.
good. Virginia, you okay with that, right?
Yes, sir.
All right. Nathaniel, you okay? Caleb?
Yes, sir, I good.
All right. Now, what is telling us that this is our AP? So we just said, Kamaya, an AP is when the terms are increasing by a value, like you're adding the same number to continue to progress your sequence. So over here, could you read me the line that says it's our AP, like tells me it's our AP? Tell me, Kamaya. Can you read the line that gives it away?
Um, a customer pays a multi by increasing the payment each month by dollars X.
$X, right? So if they're telling us
Yeah.
it increases by $X, let me give you an example, right? Let me just say X was 5. You with me? Let me just say X was 5. Let me just say
Hmm.
X was 5. So let me just say the amount of money was increasing by $5 every month. Let me just say in the first month we had $10, right? How much money I would have in the second month?
50,
How much money I would have in the third month?
20.
And this is like our AP?
Yeah.
Yeah, so it's like AP we're working with. If the customer repaid $50 in the fifth month, let's keep that in mind, and 70 in the ninth month, calculate the total amount of money repaid at the end of the 24th month. Okay, so when you read the question, let me make a little checklist, right? We know it's our AP. If it's our AP, what formulas am I thinking to use here? Virginia, do you know the formulas for AP?
Yep. Okay, so A plus N minus 1D.
And that would be the formula for what?
To figure out what term it is, right?
Exactly that. We use our formula to find the general formula to generate each term. So A of n, this is the n term, is A
Okay.
plus n minus 1 by d. Nathaniel, like it's a another formula we use for AP.
Um, this is I can't remember the exact formula. I know it's to find the sum of the terms, right?
Yeah, talk to me. S of n.
Yeah, S7. Um, so I can't remember that formula.
This has been the formula sheet. It has been the
Okay,
formula sheet.
all right, that's good.
Yeah, there's been the formula sheet. If you
Yeah,
let me just verify that though. I don't want to be telling you things here and it's a lie. Let me verify that. Um, the, yeah, it's been the formula sheet.
yeah,
N over 2 by 2a plus n minus 1 by d. Uh-huh. N over 2, yeah, by,
by 2 A1.
take a screenshot in your head. So n over 2, 2a plus
Yeah,
n minus 1 by d. Tell me.
N over 2 times 2A plus N minus 1 D.
Bet. Virginia, I feel like you might like this. Sometime during the holidays, I want to do a live going through like why all of these formulas work. So like the derivation for the equation of a circle, or like the derivation for S of n. I feel like you might like that.
Yeah, I would. I like to understand how things work. So if I just get the formula, I'd be like, if I know how it works, then yeah.
Yeah, that's the way you have to think if you want to be really good at maths. That's it. So here what? Come on, yeah. We have this end term formula and we have this S of n formula. Now, when we look at this question, Kamaya, are you seeing the first term? Did they give us the first term in the question? Did they give us the first term?
No, sir.
Nah, that's our unknown. What else do we need to know for AP? We need the
Um,
first term and we also need the what? If you forget, look at the formula. The formula has A, which is the first term, and it also has what in it?
the difference?
Right. So you need the difference. Did it ever tell us what the difference was?
No,
Nah. So that's something else we don't know. Earlier, how much unknowns is that?
2.
Two
Two,
unknowns. Anytime we see two unknowns, what comes to mind?
Um,
Two unknowns.
an equation.
a simultaneous equation.
Yeah, simultaneous equation. Now, for me to solve a pair, as I tell another the answer, a pair of simultaneous equations, I need how much equations? How much equations I need?
Two.
I need two, right? So, given the information in the question, I need to now form two equations. Which formula do you think I'm going to use out of these two to form the two equations?
The end term formula.
Yes, I'll use the end term formula. If we were talking about terms in our series, or sequence, this 50 would represent the what term? Tell me, Virginia.
The fifth term.
Right. And Nathaniel, what would the 70 represent? The which term?
The ninth term.
Cool. So here what? We're going to use A of n to form two equations. Now there's a much easier way to work the question, but I like to make our brain work for a bit. Then I'll show you the easy way out. So, Kamaya, let's work with the fifth term first. So we know that A5 is really equal to 50. And we know that?
Yes, sir.
Okay. And if I want to form an equation, I'll say 50 is equal to A. Do we know what n is? If it's the fifth term, what would n be?
N would be 5.
N would be 5, so I could say 5 minus 1. Do I know what D is?
No.
No, I don't know what D is. I'm going to simplify this, right? So we're going to have A, and what's 5 minus 1?
4.
So we end up with A plus 40. This is one equation. I want you now to help me find the other equation. Walk me through that.
Okay, so now we find an equation for the 9th term. So it'll be A9 equals A plus 9 minus 1D.
All right, continue.
Then A9 will be 70, which will be equal to A plus 80.
Big up. Come on, one time.
Mm,
I guess so, because some saying W's in the chat, because that's really like lie. Yeah.
yeah.
I turn to Kaisen up. Or like, speed. All right, cool. Nathaniel, you're gonna help me with the other part. Virginia and Kamaya and Caleb, well, they could work this and find for A and D if you want. So Nathaniel, I have the two equations. How am I gonna solve it?
Hmm. You could use substitution here.
Yeah, you could use substitution. Could use substitution. I typically prefer elimination for linear equations that are the same, but you could use substitution. If you're comfortable with substitution, we could go with that. So tell me what to do. What you want to do? Walk me through this, Nathaniel.
Um, just now, let me write this on my paper. Hold on.
So Kamaya and Virginia, you'll let me know how things are going.
Like on the chat?
I'll look it on mute, so let me know how everything going.
Well, I got D to be 5.
I also got D to be 5.
Okay, that's extravagant news. From there, you could find for A easily. I suppose you guys did elimination. Yeah,
Yep.
yeah. Because when you do
Okay.
elimination, 70 minus 50 is 20, and 80 minus 40 is 40. 20 is equal to 40. D is 5. Easy.
Yep.
So Nathaniel, let me show you how you would do this using elimination, and of course, I'll show you how to do with substitution if you want.
Okay. Yeah.
Watch. Okay, here what, right? And this extends to beyond maths. Two is more than two is too much. Two is too much. One is enough. One is enough, Nathaniel. You hear what I'm saying?
Right. I agree.
You had to eliminate one of them and stay with one of the unknowns. So, like you see how we have A and D, that is too much unknowns. That is way too much unknowns. So we need to eliminate one. So we have this equation over here. Oof. Give me a second. We have this one, and we also have this one. Just by comparing these two equations, which unknown you want to get rid of? A or D?
A.
A, I agree. That's really simple to get rid of. What would I have to do with what would I do here? Add the equations or subtract the equations from each other?
Subtract the equations. Yeah.
Correct. So what's 70 minus 50?
20.
You tell me what A minus A would be.
0.
And what would 8D minus 4D be?
40.
4 by what is 20?
5.
That's the answer. So 4D is equal to 20. Divide both sides by 4, and you see that the answer is 5.
Yeah.
Cool. We have D. What could I find for next, Nathaniel?
9 for A.
Could find for A. All right. Which equation you want to use to find for A?
I just picking random. Let's just use equation 2.
It don't matter, you know. You can pick any one and it will work. But
Yeah, I know.
good. Once you know. Because a lot of students, they would think the teacher will show them one way and they think that's the only way. You could use one or two. Don't matter. Maths is very flexible. Granted, don't break any laws.
Right.
We don't know what A is. All right, back A. What is D?
D is 5.
Cool. So we end up with 70 is equal to A. 8 by 5 is?
40.
When you move across the 40, you're going to end up with 70 minus 40. So A is what?
30.
Bam. So here what? We have A and we have D. They want us to find the total amount of money repaid at the end of the 24th month. So when you hear the word total, what comes to mind? Total.
The sum formula.
Exactly. Some formula. Virginia, Nathaniel, and Caleb, you understand, right? When you hear the word total, it kind of sounds like you're adding this, all the way to the 24th. So you're going to use S of N.
Yes, sir.
What do you think I should use for N, though?
24.
I think I should use 24, right? That makes sense. And I'm going to use the S of N formula. So Caleb, you'll help me with this part. So Caleb, we found that A was 30 and D was 5, and we want to go up to which term?
24.
So I'm going to say, well, okay, so tell me what A, D, and N would be. What is A?
Is 30. D is 5. And N is 24 minus 1.
Nah, N would just be 24. When you plug it in, over here, that would be 24 minus 1, but N is just 24. So you tell me
Oh, there. Oh, yes,
yeah,
yes.
yeah. So you tell me what to write. I'm gonna listen to you.
24 over 2. Open bracket. 2 30 plus 24 minus 1. 5. 5, yes.
Now all we have we Casio calculators, so we could plug that in fast without waste no time.
No, sir, we have no Casio calculators.
Come on, here what? Which part you located? I think we had this
Some.
discussion before, but which part? Sawa, right?
Mm-hmm.
Okay, I'll try to make an arrangement to give you a Casio.
Okay.
No promises, but like if I in the area, I'll try to.
Okay.
Okay, so when you plug that into the calculator, well, of course, if you have a shop, try to simplify before you plug it in. But you should be able to work it. It's not a problem. 24 over 2 is 12. 2 by 30 is 60. 24 minus 1, that is 23, and 23 by 5. Okay, so that's 100, 115.
Low,
Let me just
low
verify.
key, sir.
Yeah, talk to my Kamaya.
That's
I don't know if you guys got this.
Yes, sir.
$2,100. All right,
yeah.
2,100. That's the answer. Here what, again, anytime you see two unknowns, just know you had to form two equations and you solve simultaneously. That's what you had to do. So you all could take a screenshot of the working And now I'm going to present the alternative method. Virginia, if you was in the add maths live, you probably see the alternative method. Probably.
Yep. But I kind of don't remember, but I know I saw it.
Okay, bet. Don't worry. Now, take the screenshot, guys, and we're going to move on to the alternative method. All right, 3, 2, 1. Okay, cool. Gonna move on. So, Virginia, I want you to think. I want you to use our big brain. Try to figure out an alternative method that does not involve simultaneous equations.
Okay. Let me.
If only you had a beard. If only you had a beard.
Well, I
Yeah.
figured you could see me. I don't know. I don't know, sir. I mean, you could probably find how much you get for 1 month and maybe multiply or something by the 24. I don't know.
Okay,
Hmm.
wait. Let me go back to the main things I need to know for AP.
Okay.
If I want to figure out the end term or the sum, I need to know what two things. What two things I had to know?
Okay, so you gotta know the common difference and the first term.
Good. What if I tell you we could find the common difference real easy? Like real easy. Real simple.
Okay. Would you like to have to? You know what? Never mind. Never mind. Yeah. Let me just hear.
Okay. What did they give us? Any question?
They gave us the 5th month and the 9th month.
So here I go and do, right? So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Everybody okay with that?
Yes, sir.
Kamaya, Nathaniel, Caleb, like all understand I put 9 numbers, right?
Yes, sir.
Okay. By the fifth, we're gonna put by the fifth.
50.
$50.
I gotta put 50, right?
Yeah.
Stay with me. Waiting, I'm gonna put my 9.
70.
Gonna
70.
put gonna put 70. Now, Kamaya, we know that for every consecutive term, this is our AP, right? So you're gonna add, and they say it was increasing by X.
Yes, sir.
So like from the fifth term to the sixth term, I would add what? It was increasing by what again?
X.
Right. So in the 6th month, it will have 50 plus what?
X.
Good. Now let me use that trend going forward. Oh no. Oh no.
So.
Anyways, from the 6th to the 7th term, we're gonna add what?
2x.
Now we're gonna add X again.
Oh.
7 to the 8th term, we're gonna add what again?
X.
X.
And to go from the 8th to the 9th term, we gotta add to the 8th term.
X.
So here how simple this is, it? Now the difference, what's the difference between 50 and 70?
20.
4x.
And 20, right? And if we're looking at what we added, how much did we add going from 50 to 70?
4.
4x.
Right. So the difference between 50 and 70 is 20, which could be expressed as 4x. So we know that 4x has to be equal to what?
20.
Yeah.
20.
So how would I find for x?
20 over
Divide.
4.
And that is it. You find for x without using no complicated formula. Everybody okay with that?
Yes, sir.
Yes, sir.
Now here what? You could do the same thing to backtrack to find the first term. If the fifth term is 50, what would I do to get the first term? Anybody want to tell me? How much okay, if I wanted to go from the fifth term to the fourth term, what would I do?
Minus 5.
Yeah, I would minus 5. Virginia, you understand that?
Yeah. So you
If
just
I,
have to like subtract 20.
yep, that's it. Everybody seeing that, right? If I want to go from the fifth term to the first term, I have to minus 4 sets of 5. What's 4 sets of 5? What would that be?
20.
20.
20. So, Kamaya, if I want to go from the fifth term to the first term, I really have to minus what? Add a minus.
20.
Yep, you really you understand that like truly.
Yes, sir.
All right, and if I minus 20 from 50, what would I end up with for the first term?
30.
Yeah, and just like that, without any simultaneous equations, we actually figured out A and D. What do you think about that?
Awesome.
Absolute cinema. Kamaya, was that hard or that was easy?
It was easy.
Right.
But
Think,
so our way of doing this without writing 9 numbers. Oh no.
that is why the formulas exist. The
Oh well.
formulas,
Yeah, yeah.
the
But it says
formulas.
like easier way.
I feel like it
So
is easier. Yeah? Like, okay, compare like this amount of writing to this amount of writing. You know what I mean?
okay.
Yeah. And of course, if you wanted, you could have left out like the 6, 7, 8, and you could have left out the 1, 2, 3, 4.
Mm-hmm.
I put any numbers there in between, say I don't understand.
Mm-hmm.
But yeah. Because think about it, if I want to go from 5 to 9, how much was the difference between 5 and 9?
4.
4.
So I would have had to add 4x's. So 20 is equal to 4x, x is 5. Easy. Difference between 1 and 5 is what?
4.
4. I taken away 5 every time. So 5 by minus 4, that's minus 20. Minus 20 from 50 is 30. You don't have to put the 2, 3, 4 on the 6, 7, 8. Heck, if you wanted, the working could have just looked like this. You have the first term here, you have the fifth term, and you have the ninth term. The ninth term, yeah. The fifth term was 50. What was the ninth term?
70.
And Kamaya, how much terms we have between 5 and 9?
4. Well no, 3.
4. Well, the
Okay.
difference between 9 and 5 is 4, right? Look at it like
Yeah.
that. And you would have had to add 4 x's, and the difference between 50 and 70 is what?
20.
From there, and you could find for x,
Mm-hmm.
right? So you'd get x is equal to 5. And if you want to find the first term now, you would just backtrack 20. Because what's the difference between 1 and 5?
4.
Alright, so that'll be 4 x's accounted for. But you're going backwards. So you wouldn't add 4. You wouldn't add 4 x's, you'd actually take away the 4 x's. You understand? Since you're going from 5 to 1.
Yeah.
So that'll be 4 by minus 5, and you're gonna get minus 20 here. So 50 minus 20, that'll take it to 30. And well, just like that, you get A and D. I don't think you get easier on that.
Yeah.
That'd be the simplest way as opposed to doing simultaneous equations. And of course, once you have A and D, what formula would you use to find the total?
S7.
And that's in the formula sheet. Yeah, how do I get that? That's in the formula sheet. N is 24, A was 30, and the common difference was 5. So let me know if you guys okay with both methods.
Yes, sir.
Nathaniel, if you like under exam conditions and you forget to use simultaneous equations, would this be helpful?
Yes, sir. When I saw the question at first, I didn't even think of simultaneous equations. I just thought to do this.
I see. Now, if the question was like, but even then it's real simple, you could just use this hack. Like let me just say they give us the 19th term and the 51st term. What would be the difference between 19 and 51? That should be 32, right?
32.
And so I would say 32 what? I would say 32 what?
2x.
That's all.
32x.
It's not gonna be hard. No matter what, it's not gonna be hard. And like let me just say the difference between these two terms was like 700. Oh, how about find facts?
700 over 32.
That's all. That's all. Are you okay with this?
Yes, sir.
Okay. I don't know why I get blurry, but I don't know why I get blurry. All right, let's move on. 2014. Any volunteers? Any volunteers?
I will volunteer.
Okay, no problem. So, Virginia, give me a question. I'll read.
A series is given by 0.2 plus 0.02 plus 0.002 plus 0.0002 plus dot dot dot. Show that the series is geometric and find the sum to infinity of the series, given your answer as an exact fraction.
Right, so Virginia, I'm gonna blow your mind, right? Much and better
Mm.
gonna blow your mind. So, I have a question for everybody in class. Guys, um, what do you think 0.3, what is this as a fraction?
1/3.
One, everybody agree with that, right? That's wanted.
Yes, sir.
I could write this as 0.3 plus 0.03 plus 0.003 plus 0. I think I'll get the idea.
Yeah.
That's a convergent series or a divergent series?
Hmm.
Ah,
Yes.
guys.
Wait,
I
don't look back, guys. Don't look back. Don't look at all the notes. Just use all your brain.
Convergent, because again, smaller. I don't know.
Exactly.
Conversion.
When you hear the word divergent, you think of the numbers getting closer together or like they're getting apart. Diverge. What is
Getting
dive?
big.
Bigger. Now, when you hear the word converge, it almost sounds like the numbers converge. It like okay, it like collapsing, like it reaching a number. If I keep going down the line, if you notice my number is getting bigger or smaller, somebody tell me, bigger or smaller.
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 Eventually, I'll approach zero. I'll converge to zero. Would I not?
Yeah.
Okay, think about it. If I had 0.0000000000000000003, would I even care about that number?
Nah, sir.
No,
No.
sir.
Nah, I just put zero and done. Now, tell me, do you all think that this series or both do you think both of these series are arithmetic progressions or geometric progressions?
Geometry.
Questions.
I would say it's a geometric series. And we just said, was it convergent or divergent?
Convergent.
Convergent.
It was convergent. Good. Okay. And Virginia, do you understand that if you were to write this as a normal decimal, that would be 0.22222?
But yes, sir. Well, I understand that now. I didn't really see it like that before.
You see that now they're like, watch, 0.2 here, then 0.02. That would be 0.22. Um, this could be 0.222. Cool.
Yes, sir. I understand now. Thank you.
No problem. So they want us to show that this series is geometric. If it's geometric, it must have a what? What must it have?
Common ratio.
Good.
Ratio.
To find the common ratio, I just say the next term divided by the,
Previous to.
which is just t of n. So here what? I want you to pick some terms here from Virginia.
Okay. Let's do the basic one. 0.02 and divided by 0.2.
So plug that into your calculator. Let me know what you get.
1/10, so 0.1.
Let's verify that.
Okay.
Caleb,
So
tell me another
oh,
pair. That's okay. Caleb, tell me another pair.
0.002 over 0.02.
And when you plug that into the calculator, Caleb, what do you think you'll get?
0.01.
Nah, I guess 0.1.
Oh,
Check it,
right.
check it for me.
Um, yeah, sir.
And like, if you look at it from a decimal standpoint, if you multiply something by 0.1, the decimal space is going to shift one space to one, the left or the right?
we left.
the left isn't that what's happening here? Watch. Over here, the decimal place is here, and then over here it's 0.02. So like, watch. If I shift this decimal place to the left, that'll be 0. What?
0.
0.02.
Right? And the next term, right? If I were to shift this decimal place one space to the left, what would it now become?
0.002.
Right? Just by looking at it, do you all understand why it's 0.1?
Yes.
Yes, sir.
Cool. And we would have just shown that it is uh a geometric progression because it has a common ratio. Cool. If you want to go a step further, you could also show that the A of n formula works as well, but this is fine. But if you wanted to be extra, I mean, sure, you can prove this as well. What's the A of n formula for GP, Virginia?
I think it's AR to the power n minus 1.
Right? What's the first term?
First term is 0.2.
What's the common ratio?
0.1.
Right? And this would give me my nth term. To verify if it's true, let's check it with the first term, A1. So that would be 0.2 by 0.1 to what power?
0.
Yeah, and anything to the power 0 is?
1.
So you're just gonna put 0.2 because 0.2 by 1 is 0.2.
Yes.
Guys, is that true? Is my first term actually 0.2?
Yes, sir.
Hear what? I want somebody else to pick a term from here that we could verify. Somebody pick a term. The first, second, third, or fourth.
Third.
Third, okay. The third term is 0.002. So I'll say A what?
A3.
So I'll say 0.2 by 0.1 to the power of 3 minus 1, which we know is just going to be 2. Plug that into your calculator and let me know what you get. Let me plug it in here. 0.2 by 0.1. Do we get back? Well, yeah. Then it doesn't look like it, but yeah, it's the same thing.
0.002, yeah.
Because 1, 2, 3. That's 2 by 10 to the power negative 3. So cool. It does work. So is everybody okay with the first question?
Yes, sir.
Come on, are you okay?
Yes, sir.
Now they want us to find the sum to infinity of this series, giving your answer as an exact fraction. And I would have prelude to this. When you look at 0.333 recurrent, what do you know that is? What do you know that is?
1/3.
Third.
1/3. Cool. By the way, do you know that this question comes in Unit 2 Pure Math sometimes?
Really?
Yeah, it
Yes,
does.
I did.
Oh, I would love that. If I do pure maths.
But like they don't give it like this, so you have to figure that out. They would give you something like 0.333 recurrent, and they would tell you prove that this is a like an exact fraction, which I will show you guys after this question. But anyways, they want you to find the sum to infinity. What's the sum to infinity formula?
Well, since the ratio is less than 1, it'll be A over 1 minus R.
Right? A over 1 minus R. My first term is 0.2, and my common ratio is
0.1.
that looking like 0.18. I'll let me verify that though.
I think the answer is 1 over 45. I did this possible already with my teacher. I think so. Let's see if my memory good.
I got 2 over
Yeah.
9. Right.
Well, what's saying, boy? What's saying? Sorry about that. I don't know how I get that.
Oh,
Sorry. Yeah. The answer is 2 over 9. 2 over 9. Everybody get that? 2 over 9?
Yes,
yep.
sir.
Yes, sir.
Yes, sir.
Yeah, 2 over 9. And let me blow all your mind, right? If I were to add these terms, what's 0.2 plus 0.02?
0.22.
Right? If I add 0.22 to 0.002, tell me what I'll get, Kamaya.
0.222.
And if I add it to this, what I'll get.
0.2222.
Right. Check this. Whoa. 2 over 9 is 0.22222 recurrent. Yeah.
Yeah.
Cool. Now let me show you guys how we could utilize that for this question over here. I feel like I might get that one on the right off. I don't know. I have a feeling. So here what? Let me look at this question like if it was on a pure maths paper, right? Prove that so prove that 0.33 recurrent is a rational number. First of all, what's a rational number? What's a rational number, guys? It's not a
I
number
don't
with a
think we
rash.
can help you with that.
It's not a number with a rash. And it's not a
Mm.
number. All right. It's
Sir,
in the
international
name.
number is a fraction.
Yes, it's in the name, guys. Read this first part for me.
Oh, let's
Ratio.
have a look at ratio.
Yeah. If I write 4 to 5, what that really is?
A ratio.
4/5.
4 over 5. So if
Oh,
it's a rational number, you could write it as a ratio. You could write it as a fraction, right? Question. I think like root 2 is a rational number.
no,
No,
sir.
that would be irrational.
Exactly. Watch. When I press S to D, does it give me a fraction?
Nope.
Nope. Like pi. Do you all think pi is a rational number?
No,
Both
irrational.
Irrational. Now, some of them might be, yeah, it's a rational number because in school it is in 22 over 7. No, no, it's not a rational number. Don't believe the lies they tell you in school. Pi is actually an irrational number that goes on for infinity. Alright? 22 over 7 is just an approximation. But anyways, let me do this question. Does any This question is extremely similar to this question. Do any of you guys have any ideas as to how we tackle this question? I mean,
Well, would you break up these 0.3333?
I would. I would. So you tell me what to write.
Okay, 0.3
Wait,
plus.
let me ask
Oh,
somebody else. I feel like you know it already, Virginia. I feel like you know it already. Right? Caleb, what I say next? 0.3 plus what?
0.03.
Right? Nathaniel, what do you say next?
plus 0.003.
Kamaya, what do you say next?
0.0003.
And this would just go on now till the end of time, right? But the
Yes.
main thing I want you to notice, this is our what type of series?
Geometric.
Geometric progression.
Oh,
It is geometric, but the main thing I want to hear is that it's what?
convergence.
Right. And if it's a convergent series, eventually it'll converge to a finite sum. And if it converges to a finite sum, it'll be a rational number. That's already telling of the answer. Now, we need to find the common ratio. I think all you can see the common ratio already. What the common ratio will be.
0.1.
0.1.
Yeah, it will be 0.1 because every iteration, the decimal place just shifts one space to the left. Watch. But I'll put the full work in 0.03. all over 0.3. That's going to be 0.1. What would the next one be? Tell me one, Kamaya.
0.003 divided by 0.03.
And just plug it in the calculator to verify me not going mad. Because I don't trust myself sometimes.
It is 0.1.
Okay, good. We seen. And if we want to prove it's a rational number, what do you think I should do now? What do you all think we should do now?
Rewrite it
Times
as a
infinity.
fraction.
I can't just rewrite it as a fraction. I need
Oh,
to,
Times infinity.
yep, I'd find sum to infinity to verify that it's a rational number.
oh,
Because Virginia, we know it's a convergence series, it'll converge to a finite number. We are trying to see what it converges to see if that number is a rational number. So,
oh. Okay. Thank you.
no problem. So is it sum to infinity formula?
A over 1 minus R.
Our first term is 0.3. And the common ratio is 0.1. Bam. Absolute cinema. Peak. This is peak. Right? So is it a rational number, guys?
Yes, sir.
Yes, sir.
Yeah, it is a rational number. And what? 0.323 recurrent. That is what it is. These types of questions come in GCSE all the time. They love to bring questions like this in GCSE. If all they want, I could run some GCSE past papers. I mean, it's like the same kind of thing as hard maths, maybe a little harder, but it's like the same thing. It's literally this is literally call it hard maths. It's the same thing. That's where CXC gets the inspiration from. Hmm.
Okay, that sounds cool.
Like how at some point we were, I hope I know we history, but anybody here do history?
No, sir.
And we were
No.
under the British Crown at some point.
Yes.
Yes.
Yeah.
Yeah, and then we break free of the bonds, we get independence. And
Mm-hmm.
so we wanted to break away from the the English structure and the exams and whatnot. But actually, if you ask the parents what exam they write, they wouldn't tell you CXC. They would tell you like GCSE O levels, right? Which is like English, England from England. But that's where CSEC gets its structure from. Even though they try to break away from it, that's where they get the structure from.
Okay.
Yeah.
Yeah. So this is a nice question.
So when you're gonna run some SAT live?
You want to do SATs?
Well, yeah. So.
No problem. Yeah, I could run some SAT lives. Fun fact: I wrote the SAT. I think I get like 599 out of 600 in maths, and I do like real bad in English.
Yeah.
I think I get like 250 out of 400 in English or something. So something.
Agree.
Yeah, boy. Keep in mind, I didn't study for the SAT. I just walk in and do the SAT.
Okay, sir.
I know what I do good in the maths. I know what I do good in the maths, but the English I wasn't expecting it to be so like it was like rage beats. It was rage beats. It was not a fun time. Yeah.
So, sir, how much maths you really had to know to do the SATs? Like, to what level in our system?
CSEC maths. But the questions come a bit different though. The questions do come a bit different. If you truly understand how the maths work and how everything connected, you shouldn't have a problem doing good in it. But like if you just learn off questions and structure and formats, you might have a hard time. But if you just actually learn maths, in the sense that you understand any maths, it shouldn't be hard.
All right, that's good to know.
All right, cool. So here what? I hear they really want to do differentiation, so let me tackle that. Differentiation is fun. And by the way, tell your friends that you know math vibes is who hard maths classes, and a lot of people don't know it. The class like real small. I want to get like 10 students or like 15 at some point. Preach the word. Preach the word. Yeah.
Okay, sir. But sir, we can't give them the jewels. We can't spread. We need to keep this on lock.
But like
Underground.
I need to make a living too. I need to
Okay, okay.
how you
Yeah,
think
you see all them free lives that as we doing, you need some money.
yeah. Like how you think I'm gonna be able to sponsor Casios for students? Think about these things.
Okay, okay.
Yeah. Okay, cool. Differentiation. What do you think differentiation is, boy? Something different? What do you think differentiation is?
I low key forget what.
Differentiating.
Differentiation. I'm not an English teacher. Differentiation. The funny thing is, I just spelled it. I just spelled it. I'm pretty sure this is the correct spelling. Differentiation. All right. A lot of students don't know what differentiation is, you know. When we differentiate, we actually find an ingredient function.
Of a
Yes.
tangent, right?
Yeah, that's what we're doing. We are finding the gradient function tangential to a point. Probably saying, whoa, what? Oh, what does he mean by this? My brain is fried. Are they not seeing the screen?
No, I
Yeah,
was just
no,
about to say
sir.
that.
Ah, why is that? Okay, it should be seeing the screen now. Yeah, so
Yeah.
differentiation is a gradient function tangential to a point along a graph. Let me show you what I mean by this. Guys, what is this?
A
A
straight
line.
line.
Do you think the gradient changes for a straight line?
Never.
Last.
No.
Wait, do you all know what gradient is? I want to make sure.
Change in y over change in x.
Right, gradient is just a ratio between the change in y over change in x. It tells you how steep the graph is. So this is a line, and it would be in the form y is equal to mx plus c. So if I were to find the gradient between these 2 points, and I were to find the gradient between these 2 points, would it be different or would it be the same?
The
The same.
same.
The same.
Exactly. Do you think we need a gradient function for a line?
Nope.
No, the gradient is fixed. You don't need a function. So for a line, the gradient is fixed. Cool, the gradient is fixed. So in other words, oh, and I should probably explain this. Typically, you'll see dy over dx. Now, dy means a change in y with respect to x. So I want you to understand that dy dx really means change in y over, and dx means change in x, which we know to be the what? What do we know change in y over change in x to be, guys?
The
The
gradient.
The
gradient.
gradient.
Right, this is the gradient, m. So by definition, dy dx is literally the gradient, but the gradient of the tangent to a point. You'll know on that just now. So does everybody understand that for a straight line, the gradient is fixed. The gradient is never changing.
Yes, sir.
Okay. Let's say, for instance, we had a curve now. We had a curve. In regular maths, I'm not sure if you guys would have learned this, but let's just say you wanted to find a gradient at this point over here. How would you do that in regular maths?
Wow, we use the same formula. And
You
probably, oh no, no, no.
can do that. Guys, if I ask you to find a gradient at this point, are you all going to take a second point and do something?
No, sir.
No, you can't do that. Like, let me explain. Wait, take a second. I need you all to visualize this. I need you all to see it. Aha, cool. Okay, let me share my screen. Are you all seeing your screen?
Yes, sir.
Yes, sir.
Don't worry about the key, man. 6 over there.
Hmm.
That was for Nikolai. I wanted to show everybody that Nikolai does kind of look like Keyman 6, but
Oh, okay then.
yeah. Um, when I go to different, okay, so the purple line there is the gradient, right? When I slide, is the gradient remaining the same?
Nah, sir.
No, it's changing.
Oh, let's see it now to the eyes, right?
Yes, sir.
Yes, sir.
So is finding the gradient of a curve as simple as just y2 minus y1 over x2 minus x1?
Nah, sir.
No, sir.
No. So here what? In regular maths, let me just say you wanted to find let's just say you wanted to find the gradient at that point. What you would do is you would draw a tangent to the curve and you would then take 2 points from the tangent. That's what you would do. So maybe you might take this point over here and well, the minus 2, 4. Truth be told, you could just pick any point on the tangent. So let me run through that process again. In regular maths, if I ask you to find the gradient at this point, what you would do, you would take a ruler and you would draw a tangent to that point. And I'm not sure if you guys will learn this in school.
Oh,
Would you?
yes, sir. I don't know how I forgot that, but yeah.
Okay, good. Kamaya, Nathaniel, Caleb, be honest with me, they learn that in school, on it.
Yes, sir.
If you didn't, that's fine. Talk to me. Kamaya, Nathaniel, did you all learn this in school?
Yes, yes, sir, we did.
Okay. So if you want to find ingredient at a point for a curve, you're going to draw a tangent to the point you're interested in. And what you would do is you would then take 2 points along this line. So maybe I might take a point there and I might take a point here. Really, any point on the tangent and I'll find my gradient. So that's what we would do in regular maths. Everybody with me? That's what we would do in regular maths.
Yes, sir.
So question, guys, if I wanted you all to find
Sir,
ingredient at this point, what you gonna do?
Draw a tangent and take two
excuse me,
points along
sir.
the line.
Wait, yeah, Kamaya, you're saying something. Yeah, Kamaya.
Nathaniel, so we did this before, but I low-key don't remember if we actually did this. Like, I really understand
You think
how.
you think he just laughing? You think like he just saying that to like move on?
Maybe,
I feel so.
maybe. I don't know. I don't know. I don't know.
Here what, right? For a curve, the gradient is changing at every single point. If in regular maths, if you want to find ingredient at a specific point, you're going to draw a tangent to that point, and you're going to take 2 points from the tangent and find a gradient using y2 minus y1 over x2 minus x1. That's what you would do.
Okay, I understand like the method, but like I don't understand how that's doing anything. Like how it's working.
What do you mean?
Like the logistics behind it, like how that's
Okay,
coming about.
the tangent. Okay, the gradient is just like the slope at a specific point in time. So let me show you the show you this again. You understand this? Or not?
So if I change the line, then the gradient will change. But you say so you can just find any gradient and then that's the answer.
No, what I'm saying is, okay, let's just say the question asked you in regular maths, right? Let's just say the question wanted you to find the gradient at the point -39. We are going to draw a tangent to see how that, to see what's the slope at that point, which is the purple line over there. So you see that I drew a purple line tangential to the point -39,
Yes, sir.
and that gives me an idea as to how it slopes. Okay, so
Okay.
at -39, look at the curve, right? Look at the curve, how it's shaped. If
Mm-hmm.
I want to figure out the gradient at that specific point, I'll draw a tangent to get like a snapshot of the slope at that point. Let's just say I move now. Let's just say I move to -2. The gradient would change because the slope would change. And to capture the slope, I would just draw a tangent to -24. Let's just say we went to 416. Look at how the curve, the blue, look how the curve is sloping. You see how the curve is sloping? Like it's upwards. So at the point 416, I'll draw a tangent to the point. And can you see that the tangent is a straight line?
Yes, sir.
Do we know how to find the gradient of a straight line?
Yes, sir.
How do I find the gradient of a straight line?
Y equals MS plus C.
Not really. I mean, it could compare it and it could get M, but the main thing is you would take 2 points from the line and you would use what formula?
Mm-hmm. The formula, just see.
You do
No.
quality geometry before in
Oh,
regular.
oh no, never mind. It's y2 minus y1 over x2 minus x1.
Good. So do you understand I'm drawing a tangent to the curve at the point I'm interested in? That's gonna like capture the slope at that point. We're gonna get a line. And if you have the line, you could just take 2 points on the line and you could use our formula to find the gradient at that point on the curve. You understand?
Yes, sir.
I run that back again. So at every point on the curve, can you see that the slopeness the slope is changing?
Yes, sir.
Right. So let's just say I wanted to find the gradient at -416. I'm going to take my ruler and I'm going to draw a tangent to that point to capture the slope at that point. Because the slope is not going to remain the same at a different point. So I want to find the gradient at that specific point. So I draw a tangent and I'm going to take 2 points that are along the tangent. Why are you doing this? Well, the tangent is a what? Guys, tell me, what's the tangent? The tangent is a, what's the tangent? It's a
A
what?
straight
It's a straight line. How do I find the gradient of a straight line?
dy dx.
Yeah,
Well,
but
changing x.
so I could use y2 minus y1 over x2 minus x1, which is where you're learning maths, right? And by finding the gradient of the tangent, I'm finding the gradient at the point. You know why? Because the tangent passes through the point you're interested in. So, Kamaya, can you see that the tangent passes through -416 as the only point it passes through?
Yes, sir.
Right, so by finding the gradient for the purple line, you're finding the gradient at that point. If I move to a different value, you can see that the tangent now only passes through -24, which is a different point. And to find the gradient, I'll just take 2 points along the purple line and I'll use y2 minus y1 over x2 minus x1. So let's go over here. So come on, if I wanted to find the gradient at this point of the curve, and look at how the graph is sloping. Doesn't it look like the gradient is something like that?
Yes, sir.
Right, so you're gonna draw a line tangential to this point. Now the tangent is a line that touches this point alone. It doesn't touch any other points, it just touches this point. That's kind of a bad drawing, but we'll work with it. So what you would do next, Kamaya, you would then go on the graph and you would read off any 2 points on this line. And you would find a gradient, and that would tell you the gradient um of that point.
Okay.
You understand?
Yeah.
And this is what we do in regular maths. Now we have like big boy clothes now. We like like we're growing up. We don't have to do that anymore.
Yeah.
This is regular maths. So here I was saying, wouldn't it be easier if we didn't have to draw a tangent at a point every single time we wanted to find a gradient?
Yeah.
Imagine you get a graph like this and they tell you to find ingredients. Like, it's just kind of annoying. Every time you want to find a ingredient, we're going to draw a graph. Nah, there must be an easier way to do this. So let me introduce you guys to um first principles, which is the proof behind differentiation. Did you all do first principles as yet?
Yes, sir.
No, sir.
No, sir.
Nah, sir.
No problem. So here how this gonna go. Let's just say, wait, give me a second. I just run a random graph here. You'll get what emotions just now. Which axis is this?
Five.
Y,
Y,
That's the y-axis. What axis is this?
X,
X.
X,
Now here what? I want somebody to annotate a point on this graph, and we will try to find ingredients at that point. Annotate a point on the graph. Who wanna do it? I see Caleb. Draw something there down on the graph. Take your time. I'm gonna take that like you meant somewhere over here.
yes, sir.
Okay, no problem. Cool. So what did we just discuss, guys? Like if I wanted to find ingredients at that point, using like regular math, so I gotta do.
draw a tangent.
Right.
I draw a tangent on come on, you understand that, right? I'll draw a tangent. And what would I do next? What would I do next?
Pick any 2 points on that tangent and then find the gradient
Cool.
with those.
That's exactly what I would do. Now let's look at something called approximation. You guys know what approximation is?
Yes,
Yes, sir.
Okay. Stay with me, right? Let's just say that this is some function f of x. So this is a function f of x. We know it's actually a quadratic, but we'll just say it's f of x. And we should know that f of x means the same thing as what? What does f of x mean?
Y,
Right, f of x means the same thing as y. So here what? Let's refer to this value. Come on a second. One moment. So we're gonna call this x. All right, we're gonna call this x. Now, if that point is x, anybody can tell me what this will be?
Y,
You're not wrong, but we're gonna use a different notation. So I'd plug it into the function. So the function is f of x. So I'll plug in x into it, so that'll just be f of x. So this over here is just f of x. Probably say, nah, I'm confused. Kamaya, did you do functions before?
Yes, sir.
Right. So if I put in x into the function, I mean that's just f of x, right? So I'll put the x value into the function, and the y value would just be f of x. So let me know if you guys with me so far.
Yes, sir.
Now
yes, sir.
here what I say only. Here what I say. Stay with me. Um. Uh. Give me a second. Let me make this graph a bit more curvy to like explain this. Okay, let's just say for instance that you draw this random line here. Let me just say you draw this random line here, right? Still with me, right? Let me just say I drew that purple line over there. Will that purple line be the actual gradient of this of the point over here?
No.
Nah.
Kamaya and Nathaniel, like if I just draw this purple line over here, I just draw that purple line. Does it tell us the actual? Okay, if I find the gradient of the purple line, will that be the actual gradient at this point?
No, sir.
Kamaya, yes or no?
Um,
Okay, so
no.
so let me go back to what we learned just now, right? Like in regular maths. If you want to find the gradient of this, what you would
Yeah,
do? What would you do?
but draw a straight line and pick 2 points, plug it
Okay,
into the formula.
a straight line like this.
That not straight.
Okay, a straight line like
Okay,
this.
okay. No, I thought it was just trying to give my a trick question. Well, no,
No, the line has to be what to the point. Has to be what to the point.
tangential.
Yeah. So it must only pass through this point, yeah?
Yeah.
It must only pass through this point. So that's the actual gradient. That's the actual gradient. Are you with me, right? That's the actual gradient there.
Yes, sir.
All of this will make sense, Justin. Trust. So that's the actual gradient. Let me just draw an approximate gradient. So let's just say we had some other point, right? And let me just say that this point was a distance of h away from x. So let me just say that this point over here was a distance of h away from x. If that's the case, what would I make this value here? Still with me?
F for x plus
Wait, sir. I'm talking about the x value. So if this is x and this is and like this is h, what do you think this would be,
oh,
guys?
x plus h.
Okay, if you're confused, here what I was saying, right? If I told you that this was 2 and it's 3 here, what you would tell me this is?
3
5.
minus
You would tell me 5, right? You would tell me 5. So if this is x and this is h, what would the x value here be?
X plus H.
It'd be x plus h. Come on, do you genuinely understand that? Or nah?
mm, so.
Nah.
Actually, yes.
Let
Yes,
me,
I
let me,
do.
let me run it back again. Say for instance, this was 2, right? And we want to find a point that is 3 units away from 2. What do you think this point will be?
5,
And to get 5, you would take 2 plus.
3.
Okay, so if this was x and this was a distance h from x, what does point will be here? What is x value will be?
X plus h.
That would be x plus h. Cool. So this over here, I should probably put it in red. This is x plus h. What would the y value be? If the
F
x
of
value,
plus h.
wait, so if the x value was x plus h, what would the y value? How would I find the y value?
Plug it into the function.
Correct. So what would I write, Nathaniel?
Um, I don't know why. The,
So remember the function was f of x, right? The function
yeah,
was f of x.
yeah,
So when you're trying to figure out the y value, whatever you have for x, you plug it into the function. That's what it is.
yeah.
So what do we have for x this time? What we have for x now?
X plus h.
So I'm gonna plug that into the function. So the notation will look like what? Oh god, I write it. Oh my.
Well, yeah. Yes, is f is f x plus h.
Right. So if this is the function, whatever I have for x, I'm just going to plug it in.
Yeah.
And so I'll say what over here.
Um, y is equal to x fx plus h.
Right. I'm gonna plug x plus h into the function. Cool. Now, which line represents the actual gradient at the point x f of x?
The first line.
Which tell me the color?
Purple?
Purple. Everybody okay with that, right? The purple line is the correct gradient, yeah?
Yeah.
Now
Yes,
we,
sir.
we was talking about approximation. If I draw a line that passes through the red point and the green point, will that red line be the actual gradient at this point?
No, sir.
Tell me, guys, does this line over here line up with the tangent, which is the actual gradient?
No, sir.
Yeah or no, guys? Come on, Caleb. If I draw a line passing through this point and this point, will it be the actual gradient at this point?
No, sir.
All right, Caleb, I'm a little confused. Caleb, which line over here is the actual gradient at this point? Remind me. The
The which line you say?
Yeah, which line represents the gradient at this point?
The bl- the blue one.
Nah, the blue is the curve. All right, let me run through it again, right? So, Caleb, if you want to find the gradient at a point, you're going to locate the point and you're going to draw a tangent at the point, and that would give
Yes.
you the actual gradient. So, if I wanted to find the gradient at this point, I would draw a tangent at that point. If I wanted to find the gradient here, I'd draw a tangent to that point, and I'd, take 2 points and find the gradient. So, tell me, which line here represents the actual gradient at this point?
The tangent.
Which color?
The purple line.
The purple. Everybody with Mona.
Yes, sir.
Yes,
Yes,
sir.
sir.
I change it to green, right? So it'll be less confusing. So again, which line is the actual gradient at the point x f of x? Which one?
The
9.
green line.
Good. Is this the actual gradient?
No,
No,
sir.
No.
that's make gradients.
That's a approx like Virginia said, is an approximate gradient. Kamaya, do you agree that it wouldn't be this gradient here? If you find it, it wouldn't be 100% accurate, right? It might be like close to this, but it wouldn't be exact.
Yes, sir.
Now I want to look at a phenomenon. Kamaya, if I took this point and I brought it closer to the green point, let's see what happens to the approximate gradient. Let's see what happens. Um, is it getting closer to the actual gradient or less close?
Closer.
Okay, let we close in our distance even more. Again, closer or further away?
Closer.
Ah, so what I'm suggesting, um, okay, okay, I want to see if you all could figure this out. So I'm taking the red point and I'm bringing it closer to the green point, and by doing that, the approximate gradient gets what? What happens to the approximate gradient?
It gets more accurate.
Gradient.
It starts to approach the actual gradient. Now, Caleb, I hear in your silence, you're probably confused. So let me make sure you understand this. So, Caleb, just to make sure we're on the same page, what is the actual gradient at this point? Which line?
Green line.
The green line. Good. So, Caleb, let's just say I put on a point here, and well, I had this point here, right? And I
Okay.
draw a line through this point. Would that be the actual gradient of this point?
No. See.
No. You would say it is a. It would say is a what?
Um.
If something is close but is not exact, what do you call it?
Different.
So
Well.
that's what A. Like it's close, but it's not exact. It's close, but it's not exact.
I don't know. Sir.
Like play hangman. And if you like Killer Burger this one, I think he could use it.
So you
Yes,
should
sir.
get
And I'm gonna tell you it's starting with E. Alright, so Killer, guess a letter.
L.
Hi, yeah.
Um.
Next thing I like copy any hangman, I'm thinking like notes. I see Virginia like she copying on the hangman and she notes.
We know.
Yeah, Killer, guess another letter.
D.
Ah,
So that long word and I say.
yeah, it is a long word.
Um.
Oh yeah, give Caleb some gas. Give him some gas.
You got this.
Um.
Caleb. Come on now.
Come on, it there.
Sir, I
Yeah,
can't. Sir.
Sir said it. He said it.
I said it before. Yeah.
Also,
Um.
sir, what letter he said just now?
I think he said L.
No, the letter after.
G?
It was a D.
Okay.
Oh no. Caleb, guess another letter.
K. Sir.
Where is it, K?
Yeah.
Ah, boy. I draw.
I am.
Okay, we get in somewhere. That's good. Um,
Hmm.
wait, let me just make sure it's over here. Yeah.
So Caleb, when you play in hangman, you don't put vowels.
Solopoa.
Vowels, boy.
Oh.
Vowels is a smart move because most words have vowels in them.
So is that any other A's or not?
Does that have any other? Yeah, it have another A.
It's um. I.
Okay, you're getting closer to it.
It ended in Sean.
Yeah.
Um. Um.
He can do this, He gets in there, he gets in there, he gets in there. Use your imagination. Imagination is not the answer, eh?
Nah. So yeah, the pretty T.
I'll put it to you. Well, okay.
Hmm.
Sir, he gets O anyway. I think it have an X O. You have to put for him.
Yeah, yeah.
Huh?
Wait a
What?
wait a wait a wait right. Never said
Hmm.
I'm an English teacher. I'm a maths guy. I'm a maths guy through and through. I see you're good at this folks. Yeah,
Did
Caleb,
I work
continue.
with them? um, Tiny G.
Nah. Come on, Caleb, you could do it. You could do it. It like okay, so again, I would say the context of the word again. It's not exact, but like close. Close to it.
Um, hmm. Sakata nothing.
Get some letter. Get some letter.
Um,
Anybody could think of any hints they could give Caleb? Virginia scratching her non-existent head.
The only thing I thinking about is I used to write it a lot in essay because they used to say, don't say the exact time, so you just had to like, you know?
Caleb, what you doing when you round off a number? Because remember, it's a clue.
approximation.
Right.
Right.
Yes, you saved the man.
Man.
Because Caleb, is this the act? Okay, is the red line the actual gradient?
Nah, so
You could say it is a. You could say it is a.
approximate.
Right. You could say it's an approximation because it's not the actual gradient, but it's close. So here
Yes.
what I'm saying. If I take the red point and I bring it closer to the green point, does the gradient get closer to the green line or like further away from the green line? You tell me. Compare the first red line to the second red line. Which one closer to the green line?
Uh, the second one.
The second one. So is it a better approximation or a worse approximation?
That
So guys, if I were to take okay, if I approach the green point, so if I eventually approach the green point, what would happen?
you get the actual gradient.
Yes, yes, yippee! We'll get the actual gradient. So I need to find the limit as the distance between the 2 points approach what? The distance approach what? Remember, h is the distance between them, right? Over here, if like they overlap any, what's the distance between them? If the points on
Sorry,
top of each other, if the points on top of each other, was the distance between them, Virginia?
I don't have a distance.
Zero.
Yes, Caleb, it wouldn't have a distance, it will be zero. Come on, I understand you. Do you understand that if I take the red point and I put it on top of the green point, it will be like on top of each other. So the distance between them will be zero.
Yes, sir.
Yes, sir.
Right. So, and at that point, wouldn't I get the actual gradient that I want?
Yes, sir.
Yes,
Right.
sir.
So, as the distance between the 2 points approaches zero, what happens to the gradient? The approximate gradient. So, like, as this distance between the 2 points approaches zero, like it on top of each other, what would that say about the approximation?
It would be the accurate values to be same.
The
Exactly. It would be
approximation will be exact.
exact. Yes. Yes. So this brings me to first principles, and which is where you would have seen in school. What would I write this point as? Somebody tell me what this point will be.
F of x.
Nathaniel goated for that hint boy. That's a really good hint he give Caleb. That's a good hint. He should be on like them talk shows on it. You know.
Yes, sir,
He,
I
sh-
find so.
he should be hosting a talk show. Everybody go win money.
But
That's a bad
sometimes
talk
we
show.
don't want them to win money.
Out of business.
I know that should make me that should make me do the talk show then. It would seem.
Yeah.
And like when when I things tough, and you'll be like, okay, take a chance. Take a help or something. Or they have like one what do you call it? Like when in those talk shows, you have like one hotline or something. What do you call it?
A phone, a friend.
Yeah.
I guess. Caleb, what would I call this point over here? This point over here. What is the coordinate for that point?
Uh, X,
Now take your time, right? Is the x value first? What's the x value?
um, F, X plus H,
Nah, this is the y value. This is on the y
X plus
axis.
H,
X plus h, yeah? So x plus h and the y value is what?
F, X plus H,
Cool. Now, Olive, again, the red line represents the approximate what? What does it represent?
The approximate gradient.
Good. It represents the approximate gradient. But we know it will approach the correct gradient if the distance between them h tends to 0. So therefore, I could say that the first derivative f prime x, or in other words, dy dx, is just actually the limit as h approaches 0 for the approximate gradient. It's looking complicated, but it actually not. Stay with me. And we know how to find gradients of for 2 points along a line? Yeah or no?
Yeah.
Yeah. Um, we could call this x2, y2. I could call this x1, y1. Actually, I'm gonna put it the other way around. It would work out fine that way, but some way is just easier. So we could call this the first point, so x1, y1. And come on, wait, think I could call this point over here.
X2, Y2.
And you understand when we find this gradient, it's going to be the gradient for the which line? The 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 green line or the red line?
The red line.
And we know the red line is actually a what?
Approximation.
But when the distance tends to 0, the distance between the points, it actually gives you the green line. It
Yeah.
would, so I know it looking like a whole bunch of nonsense, but what I'm saying is the first derivative, oh by the way, f prime x and dy dx, it means the same thing, eh? It means the same thing. If I want to find the actual gradient, I would have to find the limit as the distance approaches 0 for the approximate gradient. And to find gradient, that's y2 minus y1 over x2 minus x1.
Yes, sir.
Yeah, so come on, what I write here? Again, this is the approximate gradient here. So you tell me what to write.
Um, Y2 minus Y1 over X2 minus X1.
Cool, but
Or
we'll
do
write.
you use the actual points?
Good. Where's y2?
Y2 is f of x plus h and then minus f of x. Sorry about the background noise. Over x x plus h minus x.
And we could simplify this. Okay, we had to understand this, like crystal clear. Caleb, is this the actual gradient?
NASA,
That's the what gradient?
approximate.
But if I make the distance between the 2 points Like, okay, if I make the distance smaller and smaller and smaller, does it get more accurate or less accurate?
More accurate.
Cool. So I hope everybody understands why we say in the limit as h approaches zero, because as the distance between the points approaches zero, it gives you the actual gradient, which is f prime x or dy dx. Let me just simplify this, and we're gonna do our past paper question one time. And if you were sticking, then we're gonna do our past paper question one time.
Right,
So
so this formula is the
this is
gradient formula
this is
or the approximate,
okay. So this is the approximate here,
right?
and this part over here makes it exact. Because, okay, this by itself is just an approximation, but when we say the limit as h approaches zero, we are closing in the distance, and we know that if the distance is zero, then the actual gradient, it'd be the actual gradient, right? So you'll see how it works just now. But do you understand that this part over here by itself is the approximation, and this one over here, the limit, when you take the limit, it will actually give you the actual gradient.
Yes, sir.
And what is x plus h minus x? We can simplify that. Let's Sama.
That would just be H.
That would just be h. Nathaniel, Kamaya, and Caleb, are they seeing that or no?
Yes, sir.
Are they sure?
No, sir.
Yes.
Repeat that,
Oh,
please.
Alright. So we have x plus h minus x. What is x minus x?
Okay, yeah. Nothing. So H. Sorry.
Just h. Don't worry. Cool. Now you're probably saying, what is this? And when will I know to use this? Well, see, XC cannot lose this. I wouldn't say it on a live, but say it here. They're not very specific. But typically, when should you use this? You should use it when they say, well, you'll see the exact question just now, but the proper name for this is differentiation from first principles. That's the proper name for it, differentiation. So if any question they ask you to find the first derivative from first principles, you use this formula. And of course, I will show you all how to use the formula to get your answer. And us CXC likes to say very, very vaguely, this is quote unquote the intuitive approach, whatever that means. Yeah, so this is the formula you need to remember at the end of the day. But of course, if you understand how they come up with the formula, you have a lower chance of forgetting the formula. All right. So that's why I went through all that drama, because I just started to learn off the formula. But I know some of you guys appreciate how things just work. And that
yes,
is
sir.
and that is what separates the average student from the extraordinary students. Anybody could become extraordinary, It's just got to put in the effort. I'm not saying that people born not extraordinary. I'm just saying like to become extraordinary, you got to put in the work. Right? Masters look so pretty sometimes, eh? Like masters look so nice. Like you just look back on it's like this looking nice. I'm gonna put it on my status to scare some people. Regular math people will be like, this what was this?
Yes, sir.
Now NC is believing, guys. NC is believing.
Yes, sir.
So here what I'm gonna do. I'm gonna put on a line here. So I'm gonna say y is equal to 5x plus 7. This is gonna blow some of your minds, eh? Genuinely. Now we know that this is a straight line, and just by looking at it, where's the gradient?
5.
We know that the gradient is 5. If I were to use this formula, do you think? Wait, if I were to use this formula, do you think I'll get 5?
Yeah.
You would get 5. Come on, yeah. Nathaniel, Caleb, like, do you all believe it?
Yeah.
Well, let me see. So, when you're differentiating, you're going to differentiate,
But wouldn't that give you approximation to 5?
and I will give you the exact answer because you're finding the limit as h approaches 0.
Oh,
Now,
okay.
yeah. So stay with me. Now, when you're differentiating, you're finding, okay, differentiation is the ratio between the output, the rate at which the output grows, in comparison to the input. Let me explain. When you differentiate this, you're gonna differentiate the output y with respect to the variable what? What's the variable here?
X.
X.
Now some of them might be real confused, like wow, real confused. I'm gonna explain something. Let's just plug in a bunch of random values for x, right? And let's see what changes. Look at this for yourself. I'm changing the value for x, and I'm gonna plug that into the function, and let's see what happens. Is another way to look at it intuitively. So if x is 0, what would I plug into this?
0 plus 7. Well, 5 by 0 plus 7.
And what would I get, guys? 5 by 0 plus 7 is what?
7.
7.
7.
Cool. I want you to put 1 into this function now. What are we getting?
I got 12.
Getting 12, right? Okay. Let's look at when you plug in 2 now. Plug 2 into the function.
17.
17.
Like I said, differentiation is the rate, is like a measure of the rate of change. So like, and when I change x, what changes as a result? By changing x, what changes?
Y would change.
Oh, let's see in that, right? Like when x was 0, y was 7. Did it remain the same over here?
No, sir.
No. Come on, you noticing that the y value changes by what? What value does it change by every single time? We just said APs and
5.
GPs. Fun fact,
5.
all linear relationships are arithmetic progressions. In case you didn't know, now you know. Virginia, you seeing that, right?
Mm.
Watch,
Yes, sir.
like
Yes, sir.
7. Watch it for yourself. 7, 12, 17. The next term, what the next term going to be? Take a guess.
22.
Yeah. So all linear progressions, I mean, all linear relationships are just APs in disguise. We just did that. So, Kamaya, when you look at this and you see that the rate of change is 5, like y changing by 5,
Yes, sir.
so that's why the gradient is 5. Hope you understand. The gradient tells you the rate at which the output changes with respect to the input. Do you know that x is the input?
Yes, sir.
And what's the output of the function?
Y.
Right. If I change the x value by 1, what does the y value change by?
1.
They change by 5.
Huh?
Look at it again. I went from 0 to 1, so I changed the x value by 1, but my
Oh,
y value
yeah.
changed by 5. Watch, look at it
Okay.
again. I start from x is equal to 1 and I went to x is equal to 2. So I changed my x value by 1, but my y value changed by,
5.
right, so 5 over 1 is,
5.
and that is why the gradient is 5, because the rate at which y is changing with respect to x is 5. Because if you plug in an input, it's just going to change, it's going to increase by 5. So that is why dy dx is 5. I hope all the, I don't just want to be like any normal lessons, right? I want all it to get like an appreciation for maths. Like I training all it for like university. Like I literally doing that. Like the stuff I showing all here will apply to engineering. Like if you're doing engineering, you do a maths degree, like this will come in very handy, right? If you're not, well, I suppose it's still good to know.
I
But
am
anyways, you gonna do an engineering degree or a maths degree?
engineer.
Okay, good. Well, please remember this because today our lecturer, I went in school and a lecturer was asking, so like, hear this, right? I don't know if all you know this, right? But I'm gonna show you a little hack here. So, Virginia, and you know that the sine graph looks like this?
Yes, sir.
Or we know that the sine graph looks like this. This is sine x. Y is equal to sine x. Now, she was saying you had to memorize the first derivative of sine x. And I was telling her you could just find the tangents at given angles, and she didn't understand what I mean by that. It took her a second, and then she was like, oh, yeah, you could do that. So even professors in university sometimes forget the basics. I don't want you all to forget the basics. Let me show you all something. Check this, right? Over here is 0 degrees, over here is 90 degrees, over here is 180 degrees, over here is 270, over here is 360. Check this. What do you think the gradient for this region is? Do you all know? Take a wild guess.
Would it be 0?
Nah, that's not 0. A gradient of 0 would look like that, because it wouldn't be steep at all.
Would it be 90?
Nah, it would be
90?
1. The gradient is 1 there.
Oh,
Then we could find the gradient at 90. What do you think the gradient of that would be?
No,
0.
that would be 0.
That would be 0. What do you think the gradient here would be?
1.
Minus.
Minus
Minus.
one.
Oh,
Minus 1. Yeah. Now, I don't know if you're realizing something, but that kind of looking like the cosine graph. Let me show you what I mean. So, when we starting off at 0, like, okay, let's think. dy dx is just the gradient function. It's just the gradient function. So, look at this for yourself. We start off with a gradient of what? What we start off with a gradient of?
1.
1.
So, we start off at 1, and then at 90, what was the gradient?
0.
Right.
0.
Okay. And then at 180, what was the gradient?
Minus
Minus
1.
1.
What graph are looking like, Olio? Graph are looking like? Okay, let me continue. Let me continue, right? Let me continue. Over here, what's the gradient gonna be?
Mm.
Mm.
So I
Would
wanna
it be?
say minus 1.
It'll also be minus 1. So like over here will
Oh,
also be minus 1. And then let's look at this region over here. What's the gradient over here? Well, wait, before we do that, what's the gradient over here?
0.
0.
0.
Which is represented by that over there. And the gradient for this section will be what?
1.
1.
So I'm going up back to 1. And it's gonna be 360. What graph is that? What graph is that, guys?
Would that be the cosine?
Yes, and that is why dy dx for sine is cosine,
Oh,
because it's just the graph of the gradient function. That's all. When you
thanks, sis.
differentiate, you're just finding the gradients at every single point. So, guys, you will nobody gonna teach you this. Like if you go on YouTube, you will learn about it. But again, when you differentiate, you're really finding the gradient function. So like if you look at the gradient of sine x, it's going to give you this graph, which is cosine. So it's another way to think about it. So dy dx for this would just be what? Tell me guys, if I differentiate sine x, what graph it give me?
Cos x.
Come on, you see now like what graph is this? What graph is this?
Yeah. Cosine.
Exactly, this is cosine. And again, if you don't understand, look at it again, right? We start off at 0. What was the gradient?
1.
So I start off at 1. Cool. Then at 90, where's the gradient?
0.
So I come over here at 0, right? Then over here at 180, the gradient is what?
Minus 1.
Right? So at 180, I'll come down to minus 1, right? Then Between 180 and 270, where's the gradient?
-1,
-1 as well. And at 270, where's the gradient?
0,
Right? So at 270, it had to be 0. And then
mhm,
going back to 360, where's the gradient?
1.
All right, so we had to go back to 1. That's the cosine graph, is it not?
Yes, sir.
So that's why
Yes.
the first derivative of sine x is actually cosine x. And you can do the exact same thing for cosine x to find the first derivative of it. Yeah. But anyways, let me get back on track. So here what? I want to use differentiation from first principles to show that the gradient here is 5. And guys, do we know that dy dx means the gradient? Do we know that? dy dx is the gradient. Do we know that?
Yes.
Yes.
Right, because dy dx literally means the change in y over the change in...
X.
X.
Cool, there we go. So I'm going to find the limit as h approaches 0. And it's f of x plus h. Now, you're not seeing it, right? But isn't this a function?
Yes,
Yes.
sir.
Okay,
Yes.
instead of saying y is equal to 5x plus 7, where's another way I could write that?
Y equals mx plus
Nah,
4.
uh, nah.
F of x is equal to 5x plus 7.
Yep, because y is the same thing as f of x. F of x is equal to 5x plus 7. Now, if you're using differentiation from first principles, notice that, okay, look at it, look at that over there. What are you plugging into the function? What are you plugging into the function?
F of x plus h.
Look inside the brackets. Where you plugging in?
Oh, x plus h. X plus h.
X plus h. So let's go ahead and find x plus h. F of x plus h. So anywhere that I see x, what am I going to write instead? Look at the brackets.
A. X plus h.
Good. So instead of writing 5x, what am I going to write?
X plus
5x plus h.
In brackets though. You got to put it in brackets.
Oh, yeah.
Plus 7. We could expand the brackets. Expand off now.
5x plus 5h plus 7.
Cool. So instead of writing f of x plus h, what am I going to put here?
5x
fx
plus
plus
5h plus 7.
Yeah. 5x plus 5h plus 7. Cool. And then I'm going to put minus f of x. Minus f of x. What was f of x?
5x plus 7.
Am I just going to write minus 5x plus 7?
no, sir. Put -5 brackets x plus h.
Nah. Okay, so here what, right, is minus f of x. So it's going to be minus open bracket what f of x is. What's f of x? Remind
5x plus 7.
Right, because it's minus the whole of f of x. You can't leave out the brackets. You need to say minus f of x. F of x is 5x plus 7. And then in the denominator, you're going to put h. Right, let's simplify the top. So come on, help me simplify the top.
It will be 5h.
Yeah, okay. You're real simplified here, boy.
Yeah.
All right. If I distribute the negative across all the terms, what would I get?
Minus 5x minus 7.
Right. And guys, let me ask Nathaniel this question. Nathaniel, if I simplify the top, what happen?
You'll 5x cancel out, 7 cancel out, and you're left with 5 each.
Uh-huh. I'm left with 5h over h. What gonna happen there?
Mm-mm.
It's just 5.
just 5. Now, okay, let me explain how limits work, right? You want to simplify as much as it could and cancel off and factorize as much as it could. Then you're going to plug in where you're approaching. Obviously, here you see now the H is cancel off. So will we plug H into, are you seeing that H anywhere to plug 0 into?
No.
Come on, yeah. Are you seeing, okay, did we end up with a H anywhere to plug a 0 into?
No, sir.
No. Nathaniel, you see that H remaining? Caleb, you see that H remaining?
No, sir.
No. Caleb, the H cancelled off over here.
Yes, sir.
So, like, your final answer is just 5. You don't have anything to plug 0 in. And isn't that what we said at the start? And we know that the gradient is 5?
Yes, sir.
Yes, sir.
So, I mean, the maths is speaking for itself. It's correct. Let me give you all one to do. And after we do this, after you all do this, I'll give you all a past paper question to attempt. All right, so I'm going to give you all 3 minutes to attempt something. Go. If you all had to say, would you say like my handwriting is like neat?
Yes, sir.
I should see when I write in my own notes. I could look when I'm learning, I could never write like this. When I'm actually learning, I could never write like this. But when I'm teaching, I could write like this. But when I'm learning, I was writing real scrappy. Real scrappy. Come on, yeah, I think I see your handwriting before. Did I?
Have you?
If I didn't, then something wrong. I'd tell the parents, you know, sending work to me.
What work I have to send to you? So you never communicated. I needed to send you work.
You have a point, but I mean, you should be like doing work regardless. You know what I mean? Should be doing work regardless. And sending to me. You know,
Oh, I didn't know I had to do that. Okay.
hey, do you want to be an average student or an extraordinary student?
Extraordinary.
Then you had to do extraordinary things. I mean, you can't just you can't wait for me to give you homework. You had to like you had to like do stuff for yourself. You gotta be conscientious.
Okay,
Yeah.
sir.
But sir, I didn't know that was a resource available to us. You could just do work and send it.
Yeah.
Oh, I will be
Okay,
using
but
that.
see, you will get work over this weekend because my maths test is next week. Add maths test is next week.
Well, good. Good. If all you want, I could do a hard maths live during the week.
Yeah, I will be. No, do our next Maths Live.
Okay, I do a maths live tomorrow from 4 to 10 p.m.
Okay, okay.
So I'll go on next maths live.
Nah, do the hard maths, but like,
Oh.
not next week.
Oh, but sir, where you doing any maths live tomorrow?
Coordinate geometry,
Mm-hmm.
matrices, circle
Okay.
theorem, bearings,
Okay,
factorization.
right.
Factorization like with quadratics.
Yeah,
Okay, I need that. So yeah, I'll be there.
cool. I will send a link and I'll be live on YouTube as well.
Okay.
But I don't know if I any Zoom, I'll let it talk.
Mm. All right.
That's good. Yeah,
You might not be there the whole time.
that's not a problem. Like I say, if you want to be extraordinary, you had to pay in the extraordinary work levels of work.
But some extraordinary work to do for other subjects of physics.
Maths,
Monday.
maths is the most important thing.
Oh,
maths is
okay.
maths is the holy trinity. Like maths and English, it's holy trinity. More
All
so
right.
maths though. More so maths. More so maths. I cannot bias. A low key bias. I don't know if you can tell it. Low key.
Yeah,
Not a
things.
lot, but like Yeah.
Also, in
Mm-hmm.
what instance would we ever have a H?
When you're dealing with functions that's like it's a curve or something, as you know, a line, the gradient is constant. However, so you get like a constant value, dy dx is always 5. If you do if you integrate, I say if you differentiate a curve though, like a quadratic, you'll end up having to plug in h is 0.
Hmm.
Yeah. As you'll see, we'll do a passive question just now, and you'll see how that goes.
Okay.
So
Yep,
I finished it.
tell my picture. What you get for the gradient though? I'll tell you if you're correct. What you get for the gradient?
-9.
Nice, supposed to get 8.
8.
Yes,
No,
supposed to
sir.
get 8.
What you talking about?
You're supposed to get 8. 8 is the answer.
Alright.
Yes,
You
Because
sir, I get
sure?
it. I get it. I get it.
because if you put it in the form y is equal to mx plus c, which it is not in, like watch. If you put it in the form y is equal to 8x minus 9.
Oh,
So when you work it out, you're supposed to get dy dx is equal to 8.
hmm.
So I write
So
it wrong in
you
the
catch me? Okay.
other than up in -9x.
Oh, pressure there, boy.
The reward help was just flipping it around. So instead of minus 9.8x, just 8x minus.
Yeah,
And then it was.
yeah, you could do that. You could just say 8x minus 9 and you get true. Get true. Okay, Virginia's. You got true or now?
Oh yeah, I finished a while ago. I got 8.
So what's this? Let me look at. So I'll see what you do it.
Oh,
Yeah.
sure.
Right. So Kamaya, let me see what's going on with this question. Right? Let me see what's going on. I want to make sure you're understanding this thing, Kamaya. I want to make sure you understand it. So Kamaya is the gradient minus 9.
Yeah.
Yeah, sure. The gradient is minus 9.
Oh, it's 8.
It's 8. So here what? If you want, you could rewrite it if it would make it look a bit simpler. So I want you to rewrite that for me in a simpler form, like we are accustomed seeing.
Y equals 8x
Mm-hmm.
minus 9.
Minus 9, yeah. This is confused students, right? But like all you do is just moving around stuff. You put the positive 8x over here and you put the minus 9 here, and 9 would change. Right? So 8x
Mm-hmm.
minus 9. Instead of saying y, what we could say?
F of x.
Right, so we could say f of x is equal to 8x minus 9. Yeah?
Mm-hmm.
Good.
Alright, so I sent it.
Good. And if I wanted to find dy dx from first principles, what would I do? Tell me the formula first.
dy over dx equals limit h to 0 f of bracket x plus h bracket minus f bracket x bracket over h.
Cool. Now, we have a function f of x here. So we already know what we're going to plug in for f of x. How am I going to find f of x plus h?
Um, you're gonna this one.
We could do it. So, did you all do functions in school as yet? Like composite functions on it?
Yes.
Yes.
Everything is connected, you know. All roads lead to math. Everything is connected. So, like, question, right? Come on. If inside of x I have 2 inside of this bracket, I'm gonna replace x with. Aha. So if inside of x I have x plus h in the bracket, we think I'm gonna replace x with.
Plus
Say that again?
x plus h.
Correct. That's correct. But here what?
So f.
We should probably go ahead and find for f of x plus h. So you
Mm-hmm.
tell me what to write.
Will equal 8 get x plus h
I
minus
want I
9.
want I want to hear confidence.
Yeah.
I want to hear performance. Right?
Okay.
As Marshall say, give them performance. You know what I mean?
Yes.
Yeah,
So yes.
that's to lock in. To,
Mm-hmm.
I can't erase it. Tell me. Confidence is time.
Okay. So f bracket x plus h bracket equals 8 bracket x plus h bracket minus 9.
This is what we're talking about, right? I like what I'm seeing, like what I'm hearing. Yeah.
Mm.
What next?
And now, if you expand it, you will get f of x plus h equals 8x plus 8h minus 9.
Big up, big up, big up. Right?
Mhm.
So now I could work this out. So I'd say the
Yeah,
limit as h approaches zero for
will be 8x plus 8h minus 9 minus f of x, which would be put into brackets 8x minus 9.
a little fine like Kumaya, it's like one of them ASMR videos on YouTube. Like
What?
you know how you just be hearing like the little
Yes,
clunk, little
yes,
click,
yes,
little click.
yes, sir. That's because she's have a mic right by she mouth.
Yeah, it's
Yeah,
like
I have headphones.
all
So,
right, so today guys we will be eating yeah, yeah, yeah. And like I'll put over each.
yeah.
What next?
Right. So now you know, you will expand the brackets.
Yeah.
So I get 8x plus 8h minus 9 minus 8x plus 9 over h.
I can be
Right
on lazy, so I can be
now,
on pace. Yeah. I'll see on lazy, so
okay.
I can be on pace. Oh, you can't do this in the exam though. Sorry.
Yeah, sadly.
Yeah.
Okay, so we cancel off 8x minus 8h and minus 9 plus 9, so you'll be left with 8h over h,
Yeah.
and that will cancel off and you'll get limits.
Oh,
H
it's H.
approaching 0 will be
Right.
8, and then you will get gradient equals 8
Because it all
because there's no h to substitute to
exactly.
0.
Big up yourself. Big up yourself.
Mm.
Right. So I'm a proud. I don't want to say father. I don't know, but I'm proud. I'm
Let's
a
have
proud.
young fathers out there, so
That's true. That's true.
even though I don't even think that's possible at that point.
I have a lot of children. I have like
Mm.
259 children.
Oh,
Yeah. I have a lot of children. So I just adopt some children. Yeah.
adopt.
Mm-hmm.
Okay.
So this is why I need to find some way of making money, dollars are churn into mine.
Hmm. Yeah. Makes
Yeah.
sense. Makes sense.
So let me do a pass paper question. Actually, I'm gonna let you all try the pass paper question. And I'm gonna sit back and eat popcorn. Let me
Popcorn.
I want you all to spread your wings and fly.
I don't have any wings. I am still a caterpillar.
I think you need to drink Red Bull then.
Okay.
Yeah. Go drink some Red Bull. Alright. I'm joking, eh? Red Bull. It's not the best thing for your body. Although I do indulge in the tropical flavor time to time. That's the only Red
Yes,
Bull I drink.
because just be doing too much lives and not getting enough sleep.
Well, to be fair, all those lives I did, I never drink a single energy drink. Yeah. Those
Ah,
lives do really stress me out. You eat a stress me out, not the lives.
makes sense. Makes sense.
Yeah. I could do lives, no, that's not a problem. But like you see UE, nah. I don't like UE,
But
buddy.
yeah, that's a different level of maths.
Alright. So like we have to do triple integral on thing. Or they had to do like, single integral and triple integral. Am I
What?
suck? Yeah.
No.
Mm-hmm.
Okay.
Like this. Let me show you. Crazy stuff. Crazy stuff.
Looks fun. Looks spectacular.
I know, right? I don't think it's hard though. I think it's fun. That's what I think. I think it's fun.
I think you're a nerd, but that's okay.
I am the biggest nerd you could
Hmm.
think about. I ain't taking that as a compliment. Because you have to accept who you are and you have to show your stripes to everybody. Everybody had to see it. Yeah.
She's a big nerd too. I don't know why she.
Wait, yeah. Give me a second. Come on, is this you? Purple one? And I feel like wait, let me find Natanya.
Oh no.
I feel like it's Natanya a little bit.
Yeah, I think that's pretty accurate.
Yeah, boy. There's something wrong with this one. This one looking kind of weird. It's looking kind of. It's looking kind of. What this nerd doing over here? He
Nah,
like
so that
tired?
you know.
I mean,
That is you when you don't get any sleep.
oh, what? This is his squad. This is squad. This is squad. Wait, rest of the squad. Alright, so let me not disturb you guys. I'm gonna start the timer. Go. Again, f prime x means first derivative. So they're saying use the definition of the derivative, which is what we learned, as a limit, which is what we learned, to find the first derivative. This is hilarious. I'm distracted on it, but watch this. Prove that 0.54 recurrent is 49 over 90.
So this is the memes you just be watching, right?
Yeah. Oh, that's just too funny.
So you got sad enough.
Come on, you okay? I find like you're getting offended by my joy. You okay?
No,
Come on, I don't
maybe
like
not.
boy.
Come on, is everything okay at home?
Come on, I
I
agree.
don't. Yeah, come on, it's good.
Okay, something a little mean, something like them class bullies.
I is not a bully.
Okay, okay,
Um,
yeah.
I think
So
some people say otherwise. But that's okay.
Nathaniel, I feel like Nathaniel would say you're a bully. I feel like it is bully poor Nathaniel. But like you see this question over here. If you wanted to work this question out, you'd have to write it as a sum for a convergent series and you find sum to infinity, which is what we learned. So you could actually do this question. Yeah.
Yeah.
Oh, okay.
Time is up. Did any of you get through?
So you
So
were showing me memes and thing. I need more time.
okay, no problem. And to be fair, 3 minutes is kinda wicked. The question itself is 4 marks. I think it should be more with more marks, but CX you can you. So again, the answer is supposed to get us 2x, eh?
Oh,
But
yes.
we'll big up
Oh,
yourself.
I was very wrong. Super duper. Super wrong.
It's the same thing we was doing the whole time, you know. It's just like different function.
Yeah, I stumped.
Ah. Yeah, Virginia, that's I would take that.
Oh,
Yeah, that's fine.
okay.
Okay. Big up yourself. So
Thank you, sir.
I'm going to let Nathaniel help me with this question, Nathaniel and Caleb. I promise you is nothing that we didn't do before. I promise. If you're having trouble with this, most likely you have a problem with functions and expanding brackets. But I wouldn't say it something different. Okay, so to start this off, we want to find the first derivative. Um, what would I use to find the first derivative? Tell me, Nathaniel. Remind me, what was the formula?
The formula for the first derivative.
Yes.
Um.
We just did it before. It was the same thing. Remember, f prime x and dy dx means the same thing.
Oh, okay. Well, then is bracket h plus. Wait, just not. That's not. Then is what's it for? I don't know. Yeah, limit h
Approaches zero, right?
approaching zero.
Over, oh,
Yeah, over h
we know it's over h, right? Yeah, over h.
is I don't know how to like express it in the formula.
Some of the formula. So the formula is f of,
F of x plus h
right?
minus f of x.
Okay, Caleb, yeah, you had attempt the question.
Yes, sir.
You had used this formula or no? Be honest.
Uh, ye, nothing.
Nah, okay. They said use the definition of the derivative as a limit. So if they say something like that, they want you to solve it using this. That's what they mean. So this is the definition of the derivative as a limit. All right. So, Kamaya, where did you get stuck? Talk to me,
I
Kamaya.
think it was my finding of f x plus h.
Ah,
Because I just got -3. But
well,
that seems
let me see how we're gonna do that. So, Nathaniel, you see an f of x plus h. So what we're gonna plug into this function?
Um. Oh, we're gonna plug f of x, which is x squared minus 3.
Nah, look at what's in the brackets. What's in the brackets here?
Fx plus h.
Nah, f is not in the brackets. What's in the brackets?
Sorry, x plus h. Yeah.
Right. So whatever is in the brackets, they're gonna replace x with that.
Yeah.
Okay, like okay, if instead of x, it was f of 5. Where do I replace x with?
5.
So nothing had changed, right? So we have
Yeah.
f of x plus h. So what do we have in the brackets?
X plus h.
So what am I going to write over here?
X plus h squared minus 3.
Wait, like this?
No, x plus h in brackets squared.
Come on, did you put brackets?
yes, I did.
Okay. Caleb, let me know if you did this or no.
Nothing.
Caleb, what you do? I'm not judging or anything. I'm just curious to know what you do.
Probably added to it from me when we first.
You know, it's the same concept, it's just a different question. Like, is the same concept. You had to use the same formula, but the function here is different. The function is x squared minus 3. The functions that I gave you all before was linear functions like 8x minus 9, 5x plus 7, but this is a different function. This is x squared minus 3.
Yes, sir.
So, Caleb, what do you think I should do next?
Um,
Or Virginia, the second
yeah,
part is
maybe
correct as well.
is it?
I was just telling Virginia her second part is correct as well. Yeah.
Um,
Thanks.
yeah.
So we have x plus h squared. What does that mean, guys? Talk to me. Everybody could, other than Virginia. Virginia know the answer.
Is
Virginia.
x squared plus h squared.
Okay.
Expand the bracket.
How much of you all think is x squared plus h squared?
Nah.
I think
This, my friend, is the most common mistake students make in maths. It's one of the most made mistakes in the history of maths. That's not correct. X plus h squared really means, okay, here what, right? If I ask you what is 5 squared, what are you going to tell me? What is 5 squared?
25.
5.
Okay, to get
So
25, you said, how you get 25? Yeah, tell me now, how you get 25?
5 times 5, 5 times itself.
Right? So if I want to find x plus h squared, what am I going to
Oh
multiply?
yeah. H x plus h times x plus h. I forgot. Like I'm supposed to know this. Yeah.
Yeah, this this
Yeah.
this is not really hard maths. This is stuff you would learn in, regular maths. It's the foundation. The
Yeah.
foundation is very important. Foundation is very important. But that's okay. We can take our time and build it back.
excuse
So,
sir,
yeah, Kamaya.
when I was doing it, I did put like outside the bracket 0 because it do have a gradient, or will it be 1?
We don't know what the gradient is, Okay, so Kamaya, this is a good point to bring up. Is this a linear function?
No, sir.
No. So in other words, the gradient is gonna be changing everywhere.
Right.
So you don't know what the gradient is. Okay,
Yeah.
when I was doing this question, this was just an example, a proof of concept. Like, okay, these are linear functions, so you could just read off the gradient. But I just use the formula so you could see it's correct as well. But okay, you see,
Yeah.
like this question, is this any form y is equal to mx plus c?
No, sir.
Nah, so you can't read off the gradient for this. You cannot. You cannot. You don't know. The gradient will always be changing. And if you don't believe me, let me graph it out and you will see what I mean. Let me graph it out and we will see a way to tell me if it's a curve or if it's a line. So x squared minus 3. What's that?
A quadratic.
It's a quadratic curve. So will the gradient be the same everywhere?
No, sir.
No. So if the gradient is not the same everywhere, will it be a number or will it be like a function?
A function.
It'll be a function because a function changes with our input. Let me explain something, right? Like with this line over here, notice that the gradient is always 5 because the gradient for a line never changes. So that's why you end up with just 5. You understand?
Yeah.
But is this a line?
No, sir.
Nah, so the gradient will always be changing. Always. So you're not expecting a constant for your gradient. You're expecting a gradient function. Because depending on what x is, would the gradient remain the same or would it change?
It will change.
And we saw this earlier, right? Let me show you what I mean. Look at this again. So check this, right? What is x over here? At that point over there, what's x?
-4.
Okay. What's x over here?
-3.
Is the gradient the same?
No, sir.
What's the x value there?
-1.
Is the gradient the same?
No, sir.
Nah, so you have to come up with a gradient function. Because the gradient is not going to be the same everywhere. Alright, let me continue. So you can't look at this and read off the gradient. Nah. Only if it's a linear equation you can do that. Right, so let's continue. So, Caleb, do you know how you would expand this?
X by X, X by E, H by X, and H by
So you see, you guys know this. It's just when you see it in a question, you fumble the bag a bit. Yeah.
Real family back.
But you know the thing, like, okay, separately, you know the concept. But when you have to work a question and combine everything, uh, malfunction. That's why practice is important. So, Caleb, where's x by x?
X squared
That is x squared. And then x by h was x by
plus
h.
HX
Right? Plus,
plus HX
see, Caleb know the thing. Right?
plus H squared
Minus 3. Don't forget the
minus
minus
2.
3. Let me simplify this now. Oh, they see any like terms over here.
H
So how much HXs we have?
2. Mm.
Yeah. Everybody okay with that? Kamaya, Nathaniel, are you okay with that?
Up to that point,
Yes, sir.
I have up to that point.
When I tell you all is like the same thing we've been doing, I promise you know. As you will see. So, Nathaniel, I just find f of x plus h. So what should I write for f of x plus h?
You should write um f f of x squared plus 2hx.
Nah.
What? Okay.
What did we just find f of x plus h to be? So we worked that out. So
Yeah.
we plugged in x plus h into the function and we simplified it. So what does f of x plus h equal to?
It will equal to the answer we found, x squared plus the 2hx plus h
Yeah.
squared.
Yes.
Yeah.
I feel like I want to make sure I understand, right? So I feel like there's a gap somewhere. I feel like there's a gap somewhere.
Nah, so I understand that.
I'm gonna go it over just for safe measures.
Okay.
So f of x plus h, what's in the brackets?
X plus h.
So anywhere I see x plus h in the function, I'm gonna replace x with,
X plus h.
and I'm just gonna simplify. Cool.
Yeah.
So f of x plus h is really just what?
F of x.
Nah.
Oh no.
What's f of x plus h?
X squared plus 2hx plus h squared minus 3.
I still feel like it have a small gap somewhere. Do you understand that this is f of x plus h? Because I
Yeah.
plugged in x plus h and I
Yeah.
simplified it.
Yeah.
Right. So instead of writing f of x plus h, what I'm gonna replace that with?
X squared plus 2hx plus h squared minus 3.
Good. Come on, are you with me, Caleb?
Yes, sir.
Yes, sir.
All right. Kamaya, you are gonna tell me this next part. It's minus f of x. So you tell me what to write.
It will be minus bracket x square minus 3 bracket.
Yep, all over h. If you are confused, it says minus f of x. What exactly is f of x? Well, f of x is x squared minus 3. But this is a whole term by itself, so to show that, you put it in brackets. You put x squared minus 3 in brackets. In the next line, you'll expand the brackets. Virginia, I feel like this is the first time I've seen your handwriting.
Yeah, it would.
Find your, I don't know, I was expecting,
Oh,
I was
that's okay.
expecting,
You know what? Sure, I'll show you my class notes. That's my scrap. When I learn it, it's be scrap. I'll show you. Don't worry, don't worry,
okay,
don't worry.
no, valid point. When I did into I was right scrappy, like, let me see, should I have a book here while doing some maths or something? Where are they? Why do I feel like this is not my book?
So I think there's a problem.
Oh no, this is my book. I just forget what I was right like when I learned this, I was right on it.
Yes, so that's how I am in school. I have a scrapbook and then I have my notebook. I'll show you. I'll show you.
Yeah, it's fine. When I write it, I was right real scrappy. Like, um, I go on shoulder later. Like I was really right scrappy, like genuinely. Like like when you're learning don't happen in like a linear manner. Like when you're learning, you just had to like right way have on paper. You just had to write it all over the place.
Yeah.
All right. So what you see in here is like not how it is right in real life. Okay, then we're gonna expand the brackets, and what we're gonna get? Come on.
Minus x squared plus 3.
Now this is the part where I think Ole could figure out. I think Ole could figure this out. I genuinely think Ole could figure this out. Um,
Yes, sir.
Let me give Ole 1 minute. Try to figure something out. I want to at least know Ole figure out something. Try to figure that out. Come on, yeah. I hope you can see the light at the end of the tunnel. I hope you're seeing it.
Yeah, making me feel like it's a trick question.
No, 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 it's not. It's not. I say time is up. Did any of you figure out anything? Guys?
Yeah. Yes, sir.
Well, Virginia, I know you figure it out. I know you figure it out. I know you figure it out. Virginia, are you like the top of your class?
How do you know? Yeah.
I don't know. Who would have thought? Who would have thought?
Oh,
Because like it is been doing a lot of work and is actually understand how it works, so that makes sense.
yes, sir. I just try my best and go about it.
Yeah, yeah. You're trying to be all nonchalant. Virginia is trying to be
Oh,
nonchalant, guys. She's trying to be nonchalant about it.
Virginia so humble.
Don't worry. You go meet Shina and Serena. Serena is another person that like kind of like you, but she's more quiet. But Serena really like Matt Sam. She like understand how it's work on him. Yeah,
that's awesome.
yeah,
Actually, I think I heard that name when I was watching your videos. Actually, yeah. Yeah.
probably. All right, so come on, Nathaniel and Caleb, will you figure out anything? Are they real quiet?
Huh. China, sir.
Caleb, tell me what you do. Like
I
after this
cancel
last.
out the x squares
Mm-hmm.
and cheese
Right. So what the next
and
going to look like? By the way, wait, Nathaniel, I see you leaving all the limiters H approaches zero. You can't do that in. I had to write that in every single line. I know it's tedious, but you had to write it. That's why I
I,
write in it. Everything I write on the screen is what I had to write in it. You can't leave out anything. Yeah. So Caleb, after I simplify it, what I'm gonna write in the next line?
2 8x plus 8 squared over 8.
Uh-huh. So Caleb, you seen anything you could do moving forward?
So I wanna think you could cancel out the x, the 8, sorry.
No, you can't just cancel off the H like a madman, eh? You had to take your
Wow.
time. You
So
had to take
it would just be H, it wouldn't be H squared.
Yeah, it will be H. And you know what this will be? What I will turn to?
2x.
2x.
Yeah. Now, here what I'm gonna do, right? Just to make it a bit formal. You see that H over here and you see that H over here, so I could factor out. Caleb, what I could factor out?
See that again, sir?
What you see in common between these two terms?
The both of them are 8.
So if both of them have H, what I could do?
Um,
Think GCF. What is GCF?
Um, great. Greatest common factor.
Yeah. So we have to factorize using GCF. So um, we're gonna factor out from this. What's the greatest common factor?
8 squared.
Nah, h squared is not the greatest common factor. I can't pull out our h squared from this.
Oh, it's
H. If I were to pull out the h, what I write on the inside?
um
So I pull out our h from this. What I write here?
2x
And I pull out our
plus
h from h squared. H squared is h by h. I pull out our h. What I write?
plus 8.
Yep. And that's over h. So what I could do?
Um,
The light is
cancel
there.
out the 8.
Yes. Cancel off these h's or
Nah, the one on the outside.
right. The light is there. The light is shining bright. So we're gonna end up with the limit as h approaches 0. 2x plus h. What to do next? Scale up.
Um,
So we're saying as h approaches 0. So
mm, mm,
so h approaches 0. So we think I should replace h with.
0,
Yeah, I should replace h with 0 because h approaches 0. So if I do
yes,
that, I'm going to put 2x plus what?
0, well, it's 2x.
And that's the answer, 2x.
Let's see.
Yeah, Kamaya, it's Anya. Talk to my guys, what going on?
So I have a question.
Talk to me.
So when you're at a point where you have two hx plus h squared over h, and
Mhm.
you have to simplify from there. How come I can't say that two hx plus h squared divided by h, the h's from the h squared and the h would cancel out, and then that h squared on top would just become h, so it would be like 2hx plus h as the answer.
You gotta be real careful when you're doing that. Like, let me show you what I mean. Say I had 5 squared plus 5 by 7 all over 5. Okay, well, in that instance, it would work. But, like, okay, I don't want to tell you any, like, shortcut or anything that could be wrong. Um, Generally speaking, you don't cancel off terms when it's in a sum. You could only cancel off things when it's in a product.
Okay,
If you want to do, what would be mathematically correct is if you split it. So what you could do is you could say 2hx over h, and then you could say plus what? Let me see if you get what it's trying to say.
plus h times h, I don't know.
Okay, so
I,
I'm trying to
is
split
it
this, right? So plus h. Check this, right? If I had 4 over
oh
3 plus 1 over 3, what would that be equal to?
one?
Right? But if you
No,
would,
no, yeah,
you're correct.
okay,
Actually, no, that'll be 5 over 3, right? 5
yeah,
over.
yeah. My bad.
So watch. You see how we had 4 over 3 plus 1 over 3, and we wrote that as 4 plus 1 over 3?
Yeah,
Okay. If I split it, what do I get back? Well, I get 4 over 3 plus,
1/3.
right? So you apply the same concept here for me. So I will say 2hx over h
Yeah,
plus,
plus h squared over h.
good. And then from here, you could do what you want to do.
Yeah.
You could, yeah. But if you just nah, that kind of illegal. Even though it like would work, yeah, I nah, don't do that.
All right, all right, all right.
Kind of sus.
Mm.
And Virginia had done that.
Wait, what would I have done?
I see that you had just you didn't factor out the H or split it
Oh
into it.
no, nah, I didn't.
Yeah, right.
All
So
right, so,
that's
so tell me if my note's still scrappy. Let me know. Let me know.
Virginia like she want to try to prove her wrong.
Yeah.
Okay,
Yes, sir. Some of them are your notes, actually.
that's crazy.
Yeah.
I got send you notes in the chat.
Okay.
This is crazy.
See, sir, and he didn't believe me.
That's crazy, guy. Look at that. Look at that, guys. That was genuinely crazy.
So, it's a process. It starts off kind of scrappy, but eventually it will get like that.
Yeah. What do you think about that handwriting? I feel like the others.
Mhm.
Guys, don't be envious, like if all they want, or they could do that level of notes as well. You know what I mean? The choice is entirely up to you. If you want to be extraordinary, you could be extraordinary. Anybody can be extraordinary. Yeah.
So come
Yeah.
on, it's extraordinary too, but she being humble. She's not saying anything.
Let me see Kamaya notes now. Kamaya, some notes.
My notes not that good. What is bro putting me on? Um, just no. I used to take notes with a lot of different colors and thing, but like I don't know, I just
You get serious.
class be too caught up and I don't like to rewrite my notes and thing now because I don't have plenty time. I don't really have notes that good for you to show you, Let me see, let me see.
Well, while we on this topic, um, Virginia, I just want to explain something. In one of your notes, in general,
Yeah.
in general form, I see you have x squared plus y squared plus 2gx plus 2fy. Um,
Yeah.
it's typically
Not 2GY.
yeah, is two
Really?
is typically 2fx plus 2gy plus c. Now, in the context in which you write it, it's not wrong, but it's just different from the convention. Like,
Oh, okay. That
like
was my notes from school.
that's really interesting because when you look at the way CXC gives it in the formula sheet, watch this is how CXC
Yeah.
gives it in the formula sheet.
Oh. Well, I'll just make that change.
Yeah, that's how CXC gives it. I mean, it's not wrong. It's just different. It's just different.
Okay. All right.
Yeah. Like if you it is not wrong. Like if you say 2g x plus 2fy, then minus g minus f. But like if we're doing it here, we'll say minus f minus g.
Oh, okay.
But you have
Well,
2g 2f. So in your context, it'll be minus g minus f.
yeah.
It's not wrong, it's just a bit different.
Okay. Well, I'll just put the adjustments.
I don't want to take where it is wrong, eh? It's just different. If you
Okay.
okay with that, you can stick with that. If you want to use it like this, that's fine.
I mean, isn't it just a variable or does it have like a significance?
It's just a variable. It's just a variable. But
Okay.
the way I typically prefer this way because if you say 2fx over here, it's a direct linkage to the standard form because in the standard form it's x plus f squared, y plus g squared. So say for instance, I was given x squared plus y squared plus 8x plus 9y, well, let me just say 16y plus 5 is equal to 0. Let me just say I was given that. From that,
Yeah.
I could say f is 4, and I would say g is what?
G is 8.
I would say g is 8. And so if I wanted to write the standard form now, that would just be x plus 4 squared plus y plus 8 squared. You see how simple it makes it?
Oh, yeah.
And,
Definitely.
and what if I want to find for r is just the square root of f squared plus g squared minus c. And well, you have f, you have g, and you have c. So you can find for r and write it in this form immediately. So that's like when I see the h and the k, that's not wrong. It's just the easiest thing.
Okay.
But
Well,
everybody's
that's
different.
just how I did in school. So,
It's not a problem. Um,
but
and
thanks for
fun,
telling me what I do now.
no problem. And fun fact, let me show you something, right? Check this real fast. I don't know if you realize this, but the radius of a circle, it's always given by a right angle triangle, like everywhere.
It is.
And so if you was ever wondering where this comes from, it actually comes from Pythagoras theorem. Check this. Check this, right? It's not a circle, but this is gonna blow your mind real bad. And be like, what? Unless you knew it already, which in that case it wouldn't blow your mind.
Nah, I don't know. I'm intrigued.
Anyways, that's a right angle triangle, yeah?
Yeah.
And there's a radius.
Yep.
At any point in time, well, we could call this we could call the center xy, and we could call the a point on the circumference AB. Well, in your case, HK, right?
Yeah.
Then the radius, let me show you how it's gonna work, right? Check it out. It's a right angle triangle, and if you recall, the hypotenuse would just be equal to the sum of the other side squared. So like, check this. Consider I had this triangle here. If we're using Pythagoras theorem, that's just c squared is equal to a squared plus b squared. Yeah?
Yes, sir.
You know that, right?
Yeah.
So if we're using this diagram over here, you'll see the radius squared because that's the hypotenuse. And we'll need to figure out this dimension over here. And we'll need to figure out this dimension over here. So if this over here is x and this over here is h, then the difference would give you the distance. What would be the distance there?
Would it be X plus H?
Now let me run that back again. Let me use numbers this
No.
time. If I told you that this was 4 and this was say 7, how would you find the length of this side?
Oh, you would subtract. So that'll be 3. So it'll be X minus H or H minus X.
It would be x minus h, yeah? X minus
Oh,
h.
okay. Okay.
This is just for explanation's sake. I would say x minus h squared because this dimension over here is x minus h, and it's a right angle triangle, so x minus h squared. And then we need to look at the other dimension, which is this dimension over here. So this is on the y-axis, so this is y and this is k. So the distance here would be what?
Y minus K.
And of course, it's Pythagoras theorem, so you'll say y minus k what?
Squared.
And that's where the formula comes from. It's Pythagoras theorem.
Oh. Oh. Nah,
So
that's cool. That's cool.
because any radius you draw, it will always be given by a right angle triangle. And this will be a radius. So it's really a radius squared is equal to this squared plus this squared.
Nah, that's actually, you were right. So that really did blow my mind. I never thought of it. Well, I didn't know. So yeah, that's cool.
Now they wouldn't share this in school. There's gatekeep so
I
much
wish.
in school. This gatekeep so much. But yeah, the equation of a circle just comes from Pythagoras theorem.
Wow.
I'm gonna check Kamaya's notes.
They are nuts. They are nuts. Right.
I find it looking good though.
Right, right.
You saying that
Yeah, I
like,
find so too. I find so too.
come on, you're saying that is like, yeah, whatever.
That's just because come on, humble. Mm.
Kamaya's notes look like my notes when I try to write neat. Like when I write
No,
neat,
what you trying to say is I can't write properly and I
no,
trying.
no. I just saying like when I write my notes neatly and I try to make my notes look good, this is what it look like. It's a compliment.
Aye.
Yeah.
Okay.
Let me send Kamaya's notes. But Kamaya, why is it so pink and blue? You have like RGBs? You're like,
I have LEDs and they're
okay,
on blue right now.
I see.
So
I see in Spanish here. Long time I didn't do Spanish.
mhm.
Querer, quiero, quieres, quiere, poder, to be able to.
So you can roll your R's and you need to teach me.
Yeah, I could. Nosotros, dormir,
Mm.
duermo, duermes. I could actually speak Spanish decently. And
Decently.
I see this as chemistry. You. A little bit of quark?
You?
I'm
No, we
surprised.
never learn that. I find that
You know about quarks and
uh,
gluons and stuff?
hmm?
You know what's a gluon?
No, they don't teach you those things in school because I asked my teacher, Miss, how a proton or whatever is the smallest atom if they made up or something else? She just dismissed my question and just was like, moving on.
These school teachers need to be, I go song bad, but I feel like they don't entertain any, like, okay, you see, they don't encourage learning, what I'm trying to say. They're just doing a quote unquote job to get money.
Mm-hmm.
Like they don't realize
Mm-hmm.
the impact they could be making, if you know what I'm saying. Like when
Yeah.
when when you teach a child how things just work on at a deeper level and now they fully understand that they could go out in the world and do great things. You know what I mean?
Yeah.
If you tell them just learn this, learn that, they're gonna be disgruntled adults. And when they have a child and the child asks them why the sky blue, you could tell them some stupidness. Or like, and it would just propagate the cycle of ignorance and a lack of proper education. Knowledge is the
Mm-hmm.
key. I fed up. Scare like girl, I'm
So
angsty
you
about
will
this.
be the change.
I am I am I am the
What
person.
means
I am the person to change it. You know,
mm.
like DP means like, D means change. You know, like DYDX, and like change
This
it.
guy, this nerd.
Yeah. Come on, you're sounding like, I don't know how to describe it, but you're
Sorry, sir.
you're sure you don't you're sure you don't bully anybody in school.
I don't.
Caleb, what do you
So
think?
you have, so you have
So
good
I find she
intention.
sound like a bully, sir.
I
Bro,
find so I find so like
I'm
I feel
not
like
a bully, guys.
find find Kamaya kinda bossy boy. Kinda
Well, I've been called that before, but like, it's not a bully.
okay. A nice bully.
That is not a thing.
Oh, so
Uh,
it's a bully bully.
Let me come off Kamaya case. But yeah, guys, I will give you all a question to do for homework. Do this question. I gotta step up the. I'll make things harder for you. I'm gonna give you like a easy-ish level question. So try this one. Um, X squared. Why do I feel like it's the same one? I just change the
I
sign.
thought we never finished the question.
We finish the question. Well, um,
We never do part B.
we could do part two in the next class, right? But long story short, um, you would find the second derivative. The second derivative, you just differentiate again. Obviously, not using that long method. If you differentiate 2x, that would just be 2. There's no way to put a x, so it's just going to be a constant. So when you put 5, there's no way to put the 5, so remainder is 2. I will explain that in more detail in the next class. Alright, I'll do that. I went over the concept of differentiation today. I will show you guys more like how you typically do differentiation in the next class. Like you see how I know the derivative of 2x is 2? I'll show you how to do our next class.
Okay.
You can try this question, and if you feel like you're up for it, you can try this one. Yeah, if you feel like you're up for it, you can try 2. So these are the homework questions. Good luck. Right? Anybody wanna do the ad libs?
No, sir, you could do that.
Nathaniel, you wanna do the ad libs? You know the meme?
Son, I don't know.
You don't know this meme?
No.
Hey
Nah,
boy.
you
I
living on
know.
that rock.
Wow.
And he likes to talk about me. He likes to say
Nathaniel.
hi.
Nathaniel is Patrick Star.
Oh no.
Wait, let me know. Do you like the you don't know what I'm talking about?
Wait,
Oh
Yeah,
sir.
the
yeah,
funny
yeah,
thing, yeah, the
yeah,
funny
yeah.
thing.
Say. I
Wait,
not living on that.
wait,
I just go on.
wait, give me a second. Are you hit?
Nah, sir.
Oh, wait, why this not working, boy?
Actually, it's
Sound check
slightly
one
in
one.
the background.
Like what I hear, right? I don't know
Yeah,
if
slightly in the background.
I know hearing it.
there you go. I was saying, but anyways, good luck, guys. I find today was a good session. I low-key find out how more vibes and the format students. Like the vibes is be kind of dry sometimes on a serious note, but today was okay. Today was okay. Don't forget to share the flyer and thing with your friends to keep them employed. Um, you know what I mean? I'd like buy Casio calculators for children, so
Of
you
course, sir.
spread the word. You
Alright,
spread the
Yeah.
word.
alright.
Yeah. All right.
Don't
Later,
forget
guys.
mine, right?
Say that
Right?
again.
Bye.
Don't forget mine.
I wouldn't forget.
Okay.
Bye bye, guys.
God
Bye.
bless
Bye.
you.